Hey everyone, welcome to my stream today. It's been a little while, so hopefully everything's gonna work. Sometimes hit some technical issues here when I haven't been doing much on this Mac. As some of you may know, I been away for about 6 weeks. Had a baby, little boy, Nico. So uh, yeah, it's been it's been a little while here. Yeah, come in, say hi in the chat. Sorry, I'm just getting my desk a little oriented because also in the process of switching personal computers. So I actually got like three computers sitting here, like laptops. I have like my Mac Pro from work, which I'm using right now to stream, talk to you all, and then I got my new MacBook Air that I luckily ordered way back before the RAM shortage happened. So I got it at a decent price. M5 with 32 gigs of RAM. I just maxed the RAM. I probably could have got a Pro, but I've always liked the Air. It just fits me. And then I have my previous M1 Air, the thing that basically has been my workhorse for years and years, sitting right here too. And it's such a pain trying to migrate stuff because there's like so many active threads right now. I'm talking to AI agents like on all three computers at the same time. Anyway, we're getting there. I was just doing a solid release as usual right before the stream. That's when I'd like to release. It seems like, but what I actually wanted to do was get a Beat plugin release out as well. So we can see how that goes. But I'm excited today. Obviously, I want to talk about. You might be thinking, oh, you've been gone for 6 weeks. What could you possibly have to talk about? And honestly, I don't have much in the current event stuff. It was kind of funny. Um, I was basically doing my work, went on vacation, heard some rumors about some like mythos finally being released in the form of Fable, and then it got taken away in the whole thing. And I literally went back to work the day that Fable was reinstated. So it's like I didn't miss anything while I was gone. Um, yeah. So yeah, I don't know. I mean, I've obviously a few thoughts on this stuff in AI, because it is kind of shaping how we approach the design stuff. Obviously, this is an ongoing thing. We've been seeing this in the stream for a while now, but um, the bigger piece is I went away and these new better models came out, and I was solid repo, which I don't know if people noticed. Right before I went, I managed to close it down to about 15 open issues, and I closed every PR. I did a solid one release, solid two release, and like the repo is basically empty, just enhancements. I was pretty happy with that. And I leave, and I just get hit with like we just get hit with like a ton of issues while I'm gone, and they're all against the beta. Basically, at least a couple of people I feel like basically got their AI going and saying like bug hunt here, because like the types of stuff was very like a lot of stuff was valuable, but a lot of it like a lot of esoteric, like very weird edge cases. You're like, what the hell were they doing to trigger this? And it's like, oh no, it was like clearly LLM like doing like bug hunts, which honestly I think helps a lot because you start seeing all the different scenarios and you start needing to make technical decisions on it. Um, and the thing that started becoming really clear to me is that you know there are a lot of decision points, and a lot of them aren't completely clear. We do follow a thread to a certain degree where we're like have a bunch of axioms that we try to follow, and then try and build the system out from that. But like trying to wade through it, like sometimes the answers aren't always obvious, and part of it is the model that you're trying to build isn't always obvious. And um, I think that's really what I want to talk about today. Uh, I mean, stepping back, there's probably an even bigger question, like why are you even here? Why are you watching the stream? Why are we even talking about this stuff? When AI is writing the code, and I feel like that's why I want to broach this topic a bit too. But um, if you're already here, you're kind of already probably know why you're here. It just, I think, I think, I think there's an interesting divergence happening of like, of almost extreme opinions. And obviously where we land is going to be somewhere closer to the middle. It's just funny though, when I look at my, uh, my Twitter timeline, so to speak, or whatever, or X, the kind of discussions going on. I mean, it has a way of being hyperbolic, obviously, but it's kind of like, I mean, you know it. It's the impact that AI is having on our, the way we build or look at things is pretty profound. But at the same time, uh, it's still very clear that not many people have a grasp of what it actually means. But again, we're not really here necessarily to talk about AI, but it does fringe on some of the design aspects we have to consider and the importance of like mechanical, um, functional pieces versus like perspective pieces. Composition starts becoming a really important piece when you expect parts to be developed in isolation. I mean, this was always React's strength. And um, a lot of the struggle here working with async is composition. I think this is why async has been hard, because it's like you're threading this very imperative, like sequential thing where like this, then this, then this through a whole system of changes, and you kind of feel like you're almost like back at jQuery again. And if we want to provide the same kind of structure, like the same kind of you know, confidence, the way we can like look at the code and understand what it does, we have to figure out how to model that in a reasonable way. And as I started playing around with patterns, it was very easy to like go, oh, I can make this work this way, I can make this work this way. And I've been showcasing that on my stream for the last several months, right? But when you start going, okay, well, what if I want to make this reusable? You start kind of like having to re-examine where the responsibilities lie. And I think that's a really important part of the design of the system. And for the most part, I'm actually really, really happy. And I'll go over some of those pieces today. But there's still some open questions, some things shifted. And I'm watching the kind of community wrap their head around these patterns because they're not necessarily clear. And I think it's like Excalibur time actually, because I think this starts a bit with looking at the cycle, and I'm hoping that I can do a decent job of drawing what I need to draw today, because the challenge that I've faced every time in the past that I've been working on trying to do these diagrams is they're not very good, and it's not very clear, and that's a bit on me. But let's see if we can find ourselves in a place that's a little better. So let me share my screen here, and we can get started. All right, let's open that up. Sorry, chat, just me preambling a bit, but you guys are alive, right? Yeah, yeah. People saying hi in the chat. Sorry. I mean, if you want to see what I'm talking about, look, I mean, I'm just gonna go to the GitHub. You'll see straight off what I'm talking about in terms of um, like solid here. Let's look at issues. Let's look at closed issues for a second. I mean, this guy. There's one night, I was away from my computer, right? Like I wasn't on it, but my phone still gets emails from GitHub, and like every 20 minutes there's a new bug, and it went for like almost 24 hours. Um, but yeah, I mean, Brenly's in here too. He's been writing a lot of articles. But if you go through, this is page 1. Let's go to page 3. It's still going, right? Even though I was away, we managed, and if you look at it, I'm caught back up to where we are. These are 1.0 issues now. Again, thank you, Fable. But yeah, when did May 20th, May 20th, yeah. So around here is where um I left. So we have just over half a page of page 4, and then we have basically 3 full pages, each of 25. So close to let's say almost 100 issues against the beta that we fixed. A lot of this, like as I said, AI driven. Andrew saying that bug inheritance model need to be forced by throwing engineers into it are the same argument that React issues can be solved. You like to hear more about the Rust compiler? I mean, we could talk about it a bit. Definitely. This is one of those. I realized also, well, I mean, I started the Rust compiler. I did a lot of the work before I went on break, but I started realizing right around that time that I haven't been nearly ambitious enough. I was like, I've been worried about burning through credits and all that kind of stuff, and it's expensive, but the way the physics change, like in terms of like how much stuff costs to development, it meant that like I don't think we're being ambitious enough. I mean, it depends on where you sit and what kind of project, but I've seen a lot of discussion, and again, I don't want to get too much into AI, but where now that people have AI, they can build like anything. And for a lot of product teams and a lot of like products, it's actually kind of a bad thing. You don't want to build anything. You want to be discerning enough to only build what's important. Building everything isn't always a good thing. And I saw some videos where people talking about like the prime benefit of like big movers in the industry, let's say like a Salesforce, is like even though you might have better Salesforce, you don't have like a million of these like tiny little features for important customers, which keeps them on your platform. But the problem is like the small guys never going to be incentivized to build those things. They make them move slower. There's like lots of like mess. So once you're hooked in, you're not going to leave. So I mean, there's that whole argument. But on the other hand, you don't want to be sitting there just building a bunch of crap for one person, and you don't want to, be mired in like the complexity that comes with special casing. And I get that. And, like more AI, more slop, that whole thing. But what if your constraint, like it isn't because of your customers wanting a feature? What if your constraint is like you have a vision of how things should work, but you just literally don't have the resources to get there, right? It's not a question of like, what should we build? You know exactly what you should build. You've already scoped it as tight as you could possibly get. You literally just don't have the means to get there. Then AI is a completely different game, right? Like that's where like the Jared Bunn migration comes in or whatever, right? Like, would have he taken 3 developers and spent a year on doing that rewrite? That's pretty costly. Or can he just man it himself over a couple weeks or a month or whatever, and get to where he needs to get? There's huge benefits to the one person model. First of all, the communication barrier of like different people, different things, coordination. Sure, he takes that on himself, but he's not like having to worry about other people. In fact, one person sometimes can be faster than 3 people in that sense. And once he has a model that's capable enough of doing the work and doing the parity testing, like you can kind of just churn through it like a migration task. And as I said, this sort of brings me to even our Rust compiler thing. It's obviously not big as a project with moving bun, but that kind of task is a prime example of like prohibitives suddenly like quite possible. And let's face it, I actually don't really know Rust. The limit of my Rust knowledge is what Greg from Leptos showed me on stream. Like I get the basic concepts of how memory management and ownership work, but I don't know how to code Rust. So And the interesting thing for me, at least, is on that side is this isn't a place like performance is important, but it's already like fast enough from my perspective over the outgoing that like I don't need it to be the most performant. Like what I care about from a performance standpoint ultimately is that the developer, the not the developer, but the user of your software gets the best performance. So like I was okay with Babel. Like I'm sure if the Rust thing works, it's an improvement. You know what I mean? So yeah, look at DOM expressions. What are we doing with DOM expressions? Let's go to. I'm just going to throw this out here. Let's go to next. Let's go to packages. And I've re-scoped them. They're now under @DOM expressions. And let's go to JSX compiler. And we actually set it up so that it actually, the test suite, the fixtures, don't actually have the input. They just have the output. It actually uses the same fixtures that the Babel plugin uses to try and keep in line. And then hopefully produces very similar code. There are some differences. So there's like a translation layer. And I had some issues where I actually wrote about this a bit on X, where like Opus 4.8 just talked out of its butt, basically. Sorry, put it that like everything was parity, and like then I ran it, and like even though the tests all passed, like nothing worked. So I spent the last few days uh, getting what should I call it? Getting this back at the parity. I actually just before the stream ran a performance benchmark, which is found in the repo. And this kind of gives you an idea of some of the improvements we see, right? This is the Babel plugin. This is the native plugin. Fixtures. So this is our test suite. Babel takes 151 milliseconds to do it. Rust takes 8. And then there's a single like small to medium sized module. I guess that's a little bit on the larger side. 4.6 JSX compiler, Babel, interesting. 50 times, and then obviously something absolutely huge. And then we're seeing something like 258 times. So it's actually a pretty significant improvement for larger projects. This is only for Solid 2.0, like it's set up with the new compiler. And it's ran on my computer, so it's running on Apple Silicon. So it's on my M5 Air. But and then yeah, native throughput stays at 2027 as input grows, while Babel's per cost file grows super linearly, so the gap widens with the file size. So there you go. That seems pretty sweet. Yeah, I fully get him doing it by himself. Too many cooks in the kitchen's real. Yeah, I'm just catching up with you guys, chat. Is Veep plugin solid a good candidate for us? I mean, I don't know. The way this works is the Veep plugin is still JavaScript. It's Veep is JavaScript, you know, and then you install it installs this JSX compiler, like the core library, and then like if I go to npm, you can see uh not solid. What are we looking at? DOM expressions, JSX compiler. Yeah, the compiler, like now when we publish, we actually publish like um the latest is actually 17. Okay, so it's on next. Okay, but it actually publishes each platform, and then depending on what computer you install the compiler, it'll automatically grab the binaries for your specific computers. So I'm actually in the process of doing where it's just an option. You go plug in Solid, you just change compiler from Babel to native, and you get the Rust compiler. Okay, so what? Actually, let me see what it says here. Yeah, it's still doing some bug fixes. We'll get that going in a little bit. The interesting part of the Dethroned is that their tester.js, so Ziggy literally just implementation detail. Well, that's cool. I mean, TSRX is interesting. I haven't really. If you haven't checked up on TSRX recently, Dominic completely changed the API yet again after our stream. But I think I like where he's getting. He heard the feedback, and he generalized. Like now that see, there's no component keyword. It's just an at. This is actually almost like my proposal, if you remember, where I was just saying using a symbol. Like this is actually very, very close to the proposal that I covered on stream a few months ago, where I was talking about my idea of like how I would handle this, because he changed it so that uh, it's back to being like JSX. So like you don't have to. I'm sure message is fine, but I think he changed it so you don't have to escape the strings. He basically returned to the JSX norm. Yes, he viewed. It's not in a string. This is almost identical to what I proposed the future. So I'm actually even more stoked about this now. That being said, you have a question you got to ask yourself. Do you want to have a direct compiler that compiles this down to like and to like the same kind of output we get with our other compiler? That's one option. The other one is what they've been doing so far is like compile this down to solids JSX and then compiles. Like you don't really want the two-stage, you could argue, but the challenge is I because I was actually thinking about this. I was thinking like we could just add TSRX as another option in the Vite plugin, and then you could just like turn it on. But I was really, it's not coming to mind now. This was like over a month ago, but there was actually a real struggle with the trade-off between I guess the thing is if we adopt the straight from TSRX straight to the like the final output, then like we have to accept that everyone who uses solid has to be able to handle this format. Whereas if we only compile it down to our JSX, then this is something that's very much additive to for your projects, and there's no expectation there. So there is an interesting trade-off. That being said, it's like he took all the feedback and maybe even looked again at some of the like my original notes, and yeah, I mean, I didn't even realize how much it looked like this. Like let me see if I can find my. It's been so long. Sign in via GitHub, I think. Spicy miso ramen. What's that doing here? It's an older article. Did I write it? January. God. October last year. Expression scope. You see this use of the at sign? And then it's funny, I didn't actually use the at sign at the component level. But it's the same mentality, because I was really trying to get the JSX thing. I didn't really dislike the string thing. I came around to the string swap eventually because it made sense. It's actually completely consistent. But I would, my whole argument here is that you're not going to be JSX successor unless you like naturally kind of fit even at a copy and paste level to a certain degree with existing JSX. And I feel like yeah, the app block is actually kind of funny. I feel like that's where this is actually landed now, which is pretty cool. So I like this. I actually like this a lot. That being said, obviously, our first thing is like, let's see if we can get JSX working. This is interesting though. Are people just going to use Reactive because of AI? Who cares? We'll talk about that in a minute, or not a minute, a little bit later. I think people are starting to get my argument why this is not. That's not going to be the case. Some people are still arguing it, But the whole React is the last framework thing is garbage. See, and this is the thing I wasn't sure either. I built a plugin that uses OXC. Our Rust plugin is OXC. That's how the parser. Everything's using OXC. It's just I actually asked like the agent. I was like, "How does this interact?" And to be fair, it wasn't Fable, so at this point, I don't even know if I trust what the agent even said. But um, it basically said that the OXC plugins and Beat still JavaScript still get kind of called at like per hook level, which I'm like thinking that's not very efficient if we have to keep on going from the JS to the Rust level like at every file. But that's what they told me. It's probably wrong. So they're variable tokens, maybe. Honestly, everyone has their own personality and like how they fit like with the different agents. I think I'm starting to feel that I am biased towards Anthropic. I've used the GPT models and you know this, but even like before with 5.5 with GPT and like all 5.4 and all through the history, every time I've used an Anthropic model, even one that's like in all the benchmarks worse or whatever, I get along with the Anthropic model more. I like its attitude better. Um, I I feel like it's more thoughtful. I feel like it's not some cocky asshole. I know some people have different experience, but just like there's something that has rubbed me wrong on the conversational side of the GPT models. I don't mind it sometimes. Like GPT is like it's like sometimes this is something I often did when I was on a product teams when I was in when I was like leading product teams. I sometimes would just sit down with the sales or marketing people and just be like, let them give the whole spiel, not interrupt them, not correct them for correctness because usually they were never correct, but just listen to that and have them, then usually at some point in that conversation, because they know you're like the head of engineering or whatever, they're kind of, or like, important for architecture, they're going to sell you their idea that's going to just like make the company great because, and those ideas aren't always great, but that level of enthusiasm and that level of like, yeah, this is the thing, that's what I feel like when I talk to GPT. So maybe I'm like pre-biased towards Fable, but like there's so many times like I'm working on the hydration story and I'm like, man, this shouldn't work. I think we can't take this shortcut. We need to actually hoist these things because the ID scopes aren't going to match. Like we can't just collapse them. And it's just like, and this is even with previous uh, models from Anthropic as well, like Opus or whatever. They're all like, no, this is fine. I verified it. I set up these tests, blah, blah, blah. This is perfectly fine to take the shortcut and you get this performance gain. I'm like, yeah, but I'm sure this is going to fall apart somewhere. And they're like, look, these are the situations that doesn't fall apart. Blah, 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 And you're like, okay, let's go with that. Fable first looks in is like, yeah, this isn't going to work. This is the scope problem. This when you have the JSON. I'm like, yes, yeah, thank you for saying it better. What about this? Like feedback the previous thing, and they're like, and then it's like every time you fix a bug, and it's like, yeah, you should be aware of this. I'm like, yeah, I was actually thinking about that. That's how I feel, when it's like a completely different thing, which has made like me distrust almost every model that I've used to date, other than it. I mean, 5.6 might be great, but as I said, I think I might have an Anthropic bias. Hi, someone who has not used, doesn't use React and hasn't used all these felt. You have a question? No trouble. Yeah, I mean, and that's sort of, yeah, that's sort of the question. But I think we'll articulate this a bit better later because I do want to get into the actual meat of this. That's Happy Friday, gang. Yeah. Yeah. Did you finish 2.0? No. I mean, we are progressing. I had an interesting comment. I realized because I haven't been very public, part of it because I've been away for 6 weeks. But like someone was like, "Are we going to get more beta releases?" Beta 0 was fine, but um, you know, are they going to be, like, are we going to RC or whatever? And I was like, I realized it's because I pushed beta 0 on X and all that and said like beta starting, let's go. We're like beta 17 now. We've been releasing them at a pretty good pace. But not everyone's aware of that things are progressing. I'm hoping to move to RC. The core stuff has been getting really locked down between like the freaking 100 bug fixes that we just did. But yeah, I mean, the ways things are shaping, I'm still on schedule. I said that we have RC this summer. I'm hoping we can wrap that, get into that in the next few weeks. Then we're going to give it a run. Stuff like solid primitives is already updated. I need to go through router and start a bit. I know some development on some of the component libraries is starting too. We need to kind of move the ecosystem, so give it time. We're down to the last few really technical decisions. When I'm doing releases now, all my base examples aren't breaking. It's just like the really interesting convergences that happen when you have systems are what we're starting to see. And as a way, and we start seeing more of this, which is why I wanted to talk about it on stream when we get to it. Yeah, Fable can still be wrong. Yeah, Dylan. Definitely Fable can still be wrong. It just sometimes it's just nice having someone who's more detailed in the conversation when you're like doing trade-offs and talking through design decisions and like, but yeah, I mean, especially when working on these complicated systems, I think Fable takes the time to look at the whole code base or the scope before it answers. And maybe I haven't been using the right version of other modelers or whatever. It gives it a little bit more perspective, even if I can basically, if I want to, through prompts, make it completely do a 180 on its perspective by just like feeding it certain stuff. Like it's still very malleable, but there's like, when it comes to like, you're doing PR and you go, okay, look, it's like everything looks good. It just knows to flag you about like, hey, this might be something you want to worry about. Sometimes it's not, but like that aspect of things not slipping under the rug as much is huge. Does Claude use? No, I don't. No, I don't think so. I think the only big AI, I guess, OpenCode uses Solid, and Cursor used to use Solid, but yeah, we have no Anthropic or OpenAI connections. No, I don't. Taking videos takes too much time to publish, but I talk about a lot of the stuff on stream, and I'm going to talk about it today. Oh, for solid 1.2? No, it's a two. It's a solid 2 versus 3 switch. Um, it's the API is not as big of a change, but it's definitely not because of the timing differences and stuff. And because of some of the primitive differences and the whole thing. Like it's not a back compat thing. It's a very like view 2 to view 3 is a little different because they literally changed the API. I guess do they still support the option APIs in V3? If they do, then they're kind of running 2. Solid's migration is a tricky one, but in this day and age, I'm less worried about it. In that it's it's almost the same except for where it is. Do you know what it's like? It's like the difference between like semantics between React 15 and React 16, where like stuff subtly broke, which I know is a terrible thing to say. Um, yeah, I view this more as a view 2 to view 3 thing, to be fair. Even though, like, I could have, yeah, it's hard because like I could add a primitive level compat layer, and we talked about doing that, where like your V1 code would kind of work, but no, we made a call, and I think it's the right call where we're at right now. It is definitely a migration. It's just like it's a quick migration. Okay, I'll touch on this again. Solid Start 2, to my knowledge, I had the guys on stream back in April, beginning of April, was supposed to be coming out around May. It did not. There was some coordination issues, and it was really hard. I couldn't really step in because I was away. but essentially, some people had some life events, let's say, not just me, and it all happened at the same time. So there was like it kind of fell down the ladder of who was in charge until like basically we were, had to pull in Alexis, who wasn't really even like he was working on specific features, but really actively working on Start. So they kind of regrouped and they're kind of back on the page now. But the whole idea was that Solid Start 2 was supposed to come out independent of Solid 2 and was supposed to be basically out already or coming out very soon. So Solid 2 for Solid Start, the integration's in the process, but there's people who already use Solid Start 2, like the next version. It's called like Alpha or something in production. Some of our biggest customers, people like OpenCode, are using the newer version of Solid Start. So we need to support those people. We need to just get a release out the door that supports them, because it's a lot better than the original Solid Start release. We DaVinci did all that kind of stuff. So that needs to go out now. We could try and delay it to Solid 2, but then you're also forcing the Solid 2 migration on people who are real users. There needs to be another version of Solid Start before Solid 2 comes out. It just makes sense. It's just been delayed. So version numbering confusing a little bit, because then you're like, okay, then Solid Start 3 is the one with Solid 2. Yes, that's the way it's looking to be. But it just, there's real people, real companies using Solid Start, and they need a new major version now. Yeah, and the popularity had the two branches for a while. Yeah, that's basically what I expect. And you just major off your project, keep a 1x branch, and ride it out to the sunset. Solid 1 has been stable for so long, like with very little changes, that most of the libraries in the ecosystem probably have very little changes too. So like it's already in a place that's fairly good for riding off into the sunset. I don't expect a change like this big. It's just funny. We watched Vue 2 to Vue 3. We watched Svelte 4 to 5. These are all actually pretty big changes. React went through a few of these, not as direct because of all the back compat through, but like when they went from classes, from objects to classes to hooks, kind of go through this progress where it caused people to completely rewrite how they do their stuff. Like moving to hooks might have been back compat, but it was a complete ecosystem rewrite. So like, let's not kid ourselves there. And I don't expect us to have another one of these from like 2 to 3. It shouldn't be this kind of level of thing. This is just like 10 years of debt basically piled into one. I'm okay with this strategy. As I said, especially with the existence of code mods and AI now, every person that I've talked to, every project, huge code bases, a bunch of them are like just so big and mired in Solid 1's async mechanics, they can't really move easily either would. But universal libraries like component libraries, primitives, all those have had almost no problem moving to Solid 2.0. Like the core primitive stuff is very, very in line. A lot of the changes were made to be more instructive, to make things more strict, make things so people can abuse them less. So it ends up like for the 90% case not being a huge difference. Yeah, but it's still the two alpha, but I'm also assuming something. Yeah. I mean, we needed to make stuff stable. JSX version 4. I mean, these things happen over the years. I'm pretty like considering like other ecosystems have forced people to completely change how they write their code multiple times. In some cases, like I think the difference between Svelte 2 to Svelte 3 was huge, and the difference from 4 to 5 was huge. So that's 2 times they basically forced their whole ecosystem to change how they write their code. Vue 2 to Vue 3, complete change. We're not even doing that. So I like it's subtle, it's refined, but it's a little different. Okay, so let's that's enough preamble talk about this. Let's actually kind of get a bit into what I wanted to talk about and get back to that scala drop, because I think it helps understanding this progression. And I don't know if I want to draw this part, but think about when we were building on the web originally. We had the DOM, which is retained mode. And this whole retained versus immediate mode, if you're not familiar, it's something you should get familiar with because it kind of comes at the root of all of these discussions. Retained mode means you have something that you keep in memory that represents the UI and you mutate it. And every time you mutate it, that's what you see is what you get. The DOM is an example of this. If you add a div to it or add, an element or change an attribute, that's something what you see on your page changes. Immediate mode is like how a lot of game engines work, where they just kind of take whatever the current state is and then just kind of like render it. And then when something updates, they render it again and so on. And those kind of things are at an extreme. Reality, they both have trade-offs because immediate mode, retained mode, while very performant, it's this is like every time I try drawing, it's a mess, but it's like spaghetti because you're like you have this thing and then you're like the thing is like it's fine. I'll try and draw this for now. We might delete this drawing in a minute, but you have UI and then let's call this retained mode. What you end up having is all these arrows kind of pointing into it, mutating it. And they're coming from here. And then maybe this one cause also forks off something over here, which forks off over here. And you don't know where these arrows are coming from. And in this kind of model, when you view what these like little legs are, these are different processes, right? You're like, oh, I clicked the button and it did something, and then I'm going to update the UI here, and I navigated over here, and it's going to update the UI here, or I'm going to do some kind of interaction. All these different points are tied to some sort of process or action that you're doing, and you co-locate the information for how to update the UI basically with with this action. So this is kind of process oriented in retained mode. This is kind of the classic, jQuery is popular for it. Almost every project that's ever been vanilla DOM classically has approached this kind of scenario. It's, as I said, this can be very efficient, but like after a certain point, you're just like, how many freaking arrows? And what if this one also triggers something over here, and which is the same place this one's touching, and then this one here. Something really simple about this. But you look at this diagram, and you're like, this isn't simple. But if you just change the thing directly, each piece can work independently until you actually have to worry about how coordination works, right? This doesn't compose particularly well, but it does keep the related code, at least initially, together, because you're like, look, when I do this process, like it's a way people often think, checking out from a cart. Then the code for checking out the cart or adding an item to the cart or whatever, it gets grouped in one specific place. The problem is like now when you have to add items in the carts under different rules from different locations, do you reuse that code? Do you duplicate that code? Because like the code in there isn't just like saying, hey, add this to account. It's like literally saying, go over to where the cart icon is and put a number in there. But if that number can be updated from different places, like, do you read what's in the DOM to decide what the source of truth is? Do you go, okay, that shows a 2 now, let's make it a 3. What if 2 things happen at the exact same time? Because the source of truth here is generally in here. There might be like some data sources outside, but because it's generally baked into the UI, it can be consistent, but it's hard to see where everything's coming from. So something like React model, as an other extreme, turn this on its head, right? Because it kind of created like a pipeline, right? The thing about about thing about immediate mode, and it doesn't always have to work like it. At its base, immediate mode isn't necessarily a pipeline; it's just re-render everything. But what React did was it was like, okay, well, let's create a bucket. Let's put our state in a bucket. Let's put our projection of state, complicated. Let's just call that render in a bucket. And then let's put our actual UI down here. And then React was like, now you can do this. Sure. But before we actually get to our UI, there's going to be one arrow that goes there and one arrow that goes here. So all those weird timing issues and like what the hell's going on and all that stuff all gets handled here before anything else happens, which means that at a certain point in time, at any point in time when you're here, and in fact, let's change these arrows directions. Let's make them go this way. I mean, I guess it is this way. The data does flow this way, but you can almost look at this as almost pulling it. If you snapshot it, like here, at each point, you have to make a decision what changes have to go together, right? Like this process has to do both of these, so it does it together, but does it wait on some other process? Do we have weird chains? This one is like, look, at a given point, we do our updates, and then we ask, right? Once we cross this line, we ask. We can. This is why using arrows is odd, but we can just. I'm going to use the term here, pull. We can basically pull the information. This is why they talk about reacting a pull-based system. It's because you just put a bunch of state, and this schedules something in the future that just pulls it through. And this is a lot easier to reason about because UI is just function of state. You've heard this a million times, but I mean, we actually just spelled out the function here, right? UI is a function of state. This is the function, right? The projection, right? So like state flows through this function and outputs UI, right? Okay. Basic stuff. Okay. I'm sure you are all with me and this is nothing new. But if you squint, this section here is a lot like this section, right? There can still be a lot of messing around up here. And historically, we've been okay with that, right? The only guarantee of a UI library is that when we come out the other side, we have consistency. But it's this thing, the arrow pointing to the arrow. What if we have async? So state triggers async, which then has to feed back in. Like, what if we start finding ourselves like, do I have the tool to do this? I don't even, yeah, I probably, whatever. Maybe I'll just freehand this. What if we find ourselves making loops here? There, that's an arrow. Okay. And what if every time we touch this, we trigger this whole thing to trigger down? So our loops actually end up, even though they're kind of contained in here, they end up just overworking this side of things because because they're basically feeding back into the system. This is the use effect problem. Just another way of kind of stating it. We kind of get to this point where, and this is the problem that a lot of people have when they first see signals. They're like, they assume that the way state begets other states is using effects by doing writes, like breaking the chain. And this creates a bunch of these sort of, listen, loops around here that kind of mess with, like, we start losing control of like how many times this runs, because we're just like, this loops on this and that comes back. Like, sometimes it probably feels like a spiral because this comes back and triggers another loop, you know, and we're just looping around, you know, twiddling forever in here. And the source of that almost always is involved of us basically being in the system and then going out of the system to come back in the system again. See, like here, we're starting from outside, this is an input, and it enters the system, right? We event, click, enter. But when we're in the system, when we leave it to come back out, we lose track of the source. Like, for when this comes back in, it's no different than one of these. And except it wasn't from a user anymore. Where here, we can generally map this to a process. You know, you click a button. Once you're 3 loop-de-loos through, you don't know what your process is, because inside here, we have no knowledge of process. The beautiful thing about all reactive systems and UI libraries is they have no sense of time. They do not care. State, snapshot, pull. Time is something outside here. It's natural, because this is how we prove consistency. We make sure that we pull the stuff at the right time. So there's a time element to that. But for our world, everything is synchronous. Yeah. In both cases, you reason in terms of state machines, but in the retained version, state includes the projection that makes it bigger and messier. Yeah. The reason I want to kind of highlight this is this idea of like outside here impacting being process-based. What's beautiful about this model is that when you're in the system, this is a consistency thing. You have input to output, UI, function, state. It's a pull. Other verbs that we might be accustomed to in this case. Get. Right? This makes up a shape, essentially, because it runs through. Now, while my async work is moving these loops from outside the system and making them in state. Because if you make these loops disappear, out here stays process. Like, if async just flows through the system naturally, you don't have to leave to come back in. You don't lose the process. You set something that grabs something and chains through, and you keep that thread. You aren't looping. You're not losing it, right? As I said, reactivity, for some weird reason, everyone was like, oh, you know, every time you see Ryan Florence complain about, you know, signals or whatever, he's basically thinking that the chain is something like state, effect, writing to state, writing to effect, writing to, I don't know, right? Like that's, I'm gonna blow this up a little bit, but that's like what people are picturing in their heads when, that like this is a cycle, but it's always, that's not the case. Like let me, I don't know where to put this stupid thing, but like this is the illusion. The reality is it's always state, derivation, effect, end of loop. Effect doesn't run back in here. This is the full cycle. This is it. And you can see it here. State, derivation, the effect, the UI. This is a derivation function, essentially. Input, state, derive, in this case specifically a representation of the UI, but it could be something else. And then the actual UI side effect. this is like basic flow physics. And when you start viewing like that, the difference between React and a signals library is simply, is this one line or is this a bunch of lines that kind of weave into like a tree or graph? But it's still unidirectional. It's not this weird looping thing that I'm drawing here. This is the problem. When you don't have the right tools to handle async, you do this naturally, fetch in an effect. No, never fetch in an effect. Async is just a derivation of state. But that's only half the thing. Like, even if you solve this, because we solved this in solids stuff. I've demoed it before. I think you've probably seen it. We've solved this. Svelte async solution solves this. Async React solves this too. Suspense is a very basic version. Like initially, like the way, like say, like even like Vue, I'd say solves this to a degree, where you're just like, look, any system that can hold on async and resume in a way that doesn't block the whole system from running. Like suspense is the basic one, but when you get into something more like transitions, that's when you really unlock it, where you're not blocking anymore, or something transition like what Svelte has. Once you unlock that piece, so you have like partial halting mechanisms, then you get to keep this pattern even through async. But people, I see on examples when I post them on Twitter and people are like, oh, here's the example. I see this when people trying to do stuff even in React, getting the old mental model. The whole point of our work here is to turn async into part of the get. But not everything in the world is part of the get. I just want to say, like, as a baseline, this model is really easy to reason about. It is kind of the immediate model. It doesn't have to be under the hood, as we've shown with Solid.js. But what I want people to kind of take away from this is the first step of adopting async is essentially being able to retain the get directionality of our derived graphs. And as I said, some solutions weren't even respecting that loops were bad in the first place. But I think every modern framework has gotten there. Even like, yeah, every modern framework has gotten there. React might have been the first one to be like, if these loops remind you of that old Jin Chang talk about flux or whatever, like, good, that's where you should be going to. But as like, this is like, I don't know how big of an X I can put through this, like this is not a thing pretty much anywhere. Not good. People still write this code though. React never gave you the tools for async until recently, so you were forced to. But once you understand and can frame the problem this way, then the old model falls apart. Yeah, I joined. Which is interesting from the Angular people, because honestly, they lived through Zone.js and like the old digest. It just, when people get signals, it's like a drug. They're like, look, I can ping, 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 ping. You have to, it's not about pinpoint updates only. It's about the directional graph. The guys working on the team know this. It's just hard to communicate this to people. It's like the reason people love Vue, classically, because they're like, it's that same like reactivity makes things easy. When I change updates, like in their head, a lot of people, when they see signals in their head, they're like, yes, back to simple retain mode style stuff. Like like that's what they're thinking. You need the discipline to respect it like this. This is the mental shift. This is common in all the frameworks. Do not do this. Now, as I said, React never gave people the tools, right? Like my favorite, I've showed this on stream, but it's been a few months, so let's do it again. Continue with GitHub. Please be logged in. Yes, okay. Collections, Solitude. But I'm just going to show, because it's one of my easiest one. Brian Florence always has the best demos. But I want to like, I'm not going to show all the React versions, but I want to show this selection list version here because you can see the flow. You have some states. This is so this is like your input, signal, and then you have a signal which is derived from the states. See, one of the ways you get rid of effects is you allow your signals to also be derived, and by default it's derived from the first one in the list, but you can override it by setting it. And then this one, the city that you get is derived from whatever the selected state is. And then finally, the selected city, again, defaults to 0, but it can also be overridden. And this is just a graph that you would do in a synchronous system. This is just a lookup, this could be an array. You have a cities array, and you say, get me the city, for the selected cities for the selected state. And this is a list of all the states. It could just be an array. In my example here, these are actually async functions going to a server, but from this perspective, we don't care because we model them the same whether it's sync or async. We created the graph. And that way, when we switch to Florida, we get the cities in Florida, we go to Texas, and we do this. And obviously there's more going on in this example than that, but my point is you don't need effects to fetch data if you just make it part of the thing. Like this data fetch is driven by what is selected. This one is, just there to begin with, because if we had a country selector, then, it could be driven by that. But you can see that this is all part of the data graph. We're not creating a loop here in terms of the effects. This is directional, right? This is a get chain. It's actually cascading, which is why I like this example. You might, preload these ahead of time, in some cases, performance, all this. But generally speaking, if you don't want to load all the different cities for the different states, you're going to defer it, and it is a bit of a cascade, like especially if you had a country waterfall as well, or a country selector as well. My point though is this just flows through the shape. So what does that have to do with anything? I think people have been following the stream, following all this, kind of understand the shape. Like, we talk about this a lot. It's not hard. I've tried very hard, in a sense, to erase the async, and not in a way that is a lie. One example of erasing async that is a lie, I call it, is the await keyword. If you're awaiting things, you're basically saying, hey, this is a linear sequence, like a process. I do this, then I wait it, then I do this, then I wait it. Calling a lie isn't exactly right, but in reality, stuff happens between line 2 and line 3. It's not linear. But that's a good way to model processes, because processes do have this, then this, and this, and this. It's a terrible way to model gets, because gets are always a pull at a certain moment in time. You have multiple things in flight. You have things that are async, things that are not async. You don't want to block like that in a way that's like nothing else can move. Blocking is inherent, but it shouldn't, it becomes disruptive if you're like literally saying, sorry, I can't pull anything until, all the asyncs ready. We need to do better than that. But that's because we care about get. Now, why do I keep on emphasizing get? Because there's a different side of the async problem. Because even if you solve get, get is all about data. It's all about state. Get has no idea of process. And guess what? In your actual apps, you have processes, you have actions, you have things that happen. And you still need to be able to model that. So UI equals function of state is great, but it is only half the story. And I feel like our work that we've been doing in server full stack frameworks has made this really, really, really clear. because I'm thinking about remix loader patterns, like and I'm thinking about server components, and I'm thinking about like even like the route action style that we have start and tan stack and whatnot. It starts becoming clear that there's like two, like even React query, if you like kind of go back to it, there's two pieces. There's the get and there's the post, and they have different requirements, but they feed into it. Like the classic, like one here you have the process and the effect and everything kind of tied together, right? Here we've pushed the process outside of our system. But the important thing to understand when we do have these loops is like technically these arrows here are coming often back up from here, right? Can I bend this in the middle? Yeah, I can bend this in the middle. They are coming back up here. There is a loop. It's just not like, it's not like a automatic loop. It's not like a like mess with state kind of loop. It's like this produces the UI. So let's make this ... This produces the UI that someone will interact with that will update future state. The key part about this whole system is these kind of systems is, let's make this solid again. Is that when you initially load the page, there's a get, is like the get, right? This is when you load the page. And then on any update, so this is initial. As I said, I'm focusing, I'm looking at this very much from like server perspective, but server is a great example because server is async. When you do an update, you don't just mutate the thing. You end up actually adding a second box here that sits on top that happens first, right? There's, the post or the mutation or whatever. So, but the post isn't the thing that makes sure your UI is in sync. It just triggers the get to happen again, right? This is like invalidation via like React query, right? You update your list and then tell React query to invalidate these keys. It can be coarse grained, it can be fine grained, but ultimately we do a full cycle here. It isn't just like you do a post and then you mutate one thing usually. Like it's usually like, you could in some cases, but even if you think about it, mutating one thing is doing the get in a sense. But like, because updating one piece of state and then you have to reconcile it down to the final UI. But like generally what I'm getting at is that there is a full cycle here, right? Where you have in UI, as soon as you adopt this kind of model, a clean separation between updates and resolution. It's like it's not the job of the update to ensure that the UI is synchronous. And when you have the separation, it means you actually need different tools and different mentality. Like you should be very aware of like what is an action and what is a get. You have to get state that you need to render a page, but like when you do a mutation, that is not a get. So like I remember people trying to put like saving a to-do inside a resource in Solid. That's not what it's for. Different life cycle, right? Resources go down here, right? This is where resources sit. They're down here. What else goes down here? Create async, if you're familiar with older Solid, right? what goes up here? Actions, right? Like you, and this is very clear when you've used something like Remix, but what I'm getting at is there's a whole category of different tools that are necessary to operating this because they have different needs, right? Like what do we care about over here? We care about consistency. Let's see. What else do we care about down here? Or what other characteristics does it have? No sense of time. I mean, consistency is the main one. I'm trying to think if the yeah, I think that's the main one. You might also care about like execution, like does it rerun, does it run in order? Those are all like consistency based guarantees, right? It's a snapshot, right? Snapshot. But up here in the action side, there's sequences. This, then this, and this, and this, right? This, then this, then this, do this, then do this. They're processes. Like what I'm trying to say is these areas have two completely different sets of requirements, and in a sense need to be viewed as different things, right? This is where this is an event handler. This is a side effect, even you could argue. It could trigger it, right? Right? This side cares about boundaries. It cares about like, can I render this? Right? Like error boundaries make no sense on this because these are unbound, right? This side cares about UI. This side does not care about UI if you want to keep a clean separation, right? This side cares about state. This side needs to figure out how to, like, it might need how to, like, state is an output. It's not really a drive, like, it's not really a driver. Both post and get want loading indicators. Yes. You know where I'm going here. Because the UI ultimately wants loading indicators, but where do loading indicators belong? They kind of belong here. Loading indicators are a snapshot of state. It's an ephemeral state, but it's a snapshot of state. This is why managing your loading sequences and actions is tricky. Okay, I want to show you something a little bit more concrete now. Let's leave this. I want to show you something a little bit more concrete. What example? I want to take my simplest async example. I think I want to take my divide example. Okay. Yeah, let's take my divide example. The divide example is very simple. There is a number. When you increment the number, when you press a button, it calls the divide function that divides the number by 1, by 2, by 3, by 4, by 5, by 6, and then displays it rounded, in the UI, saying like this divided by this equals this. So there's an input and there's an output. Of course, that's pretty simple when it's sync. Here's the trick. Divide is async. We're actually, calling it. It's a promise. There's a delay on when we can do divide, and it's actually random, which makes it fun because you don't want to show the inconsistent state, which means you kind of have to wait until everything's done if you actually want to show consistency, right? So like if I press this once, you're gonna see it doesn't update until all of them come back, and then it shows a consistent state again, right? It doesn't, they don't flicker in, they all come in automatically. This is part of those guarantees that we ensure on the get, right? But we also want an affordance. We don't want to wait for, we want, see how there's 3 ... saying like, hey, I'm loading. We want an affordance. Otherwise, when we're sitting here, we don't know that we're actually doing anything. So we actually, there's 2 types of problems here, right? There is the async consistency here, which we've basically modeled our graph. This depends on this depends on this, and it's consistent automatically, which is what you're going to find in modern async systems. But then there's like, how do we show the loading state? And this one's kind of easy in that the increment is, this is more like a navigation than it is like a typical action, because the increment is synchronous. We know where we're going. We just don't know how to draw it, right? This distinction is going to be important as we kind of talk through and understand what tools to use in each case. And I think this was the thing. But the source of our change is something that we know. We have one, and when we click it, we know we have 2. We don't know what the output is, so we have to wait on it to draw. But this is more of a navigation than like a mutation, because we're not updating a database. We're not saving, we're not performing some kind of, our action isn't to save the source and then derive what we need. This is that first piece is actually synchronous and available to us. The async part is actually just resolving what to show. As I said, this is more like a navigation. But we still need to show an affordance. And the way that we've done in this example is say, show me the latest n. So don't wait for everything to settle to show n. And then if it's n is pending, like in flight, show the ... But I started thinking, I was like, what if this is not my button? What if I have a third-party component library that wants to make a button to play along with this, right? So what I ended up doing was I made the button, and I actually made a couple versions of the button. Let me see if I can find what I was working on. It was some kind of fork of divide. It should be here somewhere. Here it is. Okay. I made 2 buttons. I made button and incrementer. Okay. So we're gonna use incrementer first, because incrementer, sorry, actually it's funny, incrementer isn't in here. Incrementer takes, what does incrementer take? Incrementer takes a count. Count equals n. Okay, I think that's right. We're gonna comment a button for now. Okay, incrementer takes count. Does incrementer take anything else? On increment, of course. We need to know to update it. So on increment, call increment. So the funny thing is, the incrementing actually happens out here, and the state actually drives through here. But the point of this button is, this button knows that it's designed to show numbers. So it goes, hey, get me the latest of my count, and if it's pending, show the pending state. So yeah, this is my old example that doesn't have HMR that I based it off of. Yeah, so okay, it's doing the same thing it was doing before, right? I just hoisted it out. Now what's interesting here is, if we did something like remove the async, like remove the sync, so to speak, what you're going to see the numbers are gone, increment just updates. And you don't see any loading state because the reason that it's loading is actually being fed in from above. The component itself just knows that, hey, look, I'm building a component that if my source here is loading, incrementer is a terrible example. A dropdown like we have in the country example that I was showing earlier is probably a better example of something that's of the same class. But because I want to show them both side by side, we're going to keep incrementer. But like an example of this is our select component here. If we pull this into a component and generalized it, yeah, here it is. We would say like, hey, this is props.option. This is the options we send to our select. Right. What we would do, we'd say is like, we'll disable the select if our options are pending. So this is a very simple thing saying like, look, I can build a generic component that says that, hey, if something I need to render isn't ready, I can show a loading affordance. I don't care what that thing is. I don't care about how you use me in my app. I'm just saying like, look, if what I need to render, my data isn't ready, I have the ability to show an affordance. And if it is ready, then you can pretend like it never existed. As I said, there's no async anymore. This code still just works because it just doesn't need an affordance. So this generic component has a way of showing its count. And then when you go, hey, I actually do have an async sync on it. And actually, this is funny. This is one of those, like, if a tree falls in the woods kind of scenarios, because it actually doesn't block the rendering. It actually doesn't care about those memos. It's not that they're lazy. It's actually that you need an actual sync for async to happen. Otherwise, you don't see it. Now it's doing it again, where it's showing the loading state. I baked something generic into my component now, and it's completely compositional. It just, hey, I have a button. Now, this isn't the way you would generically use a button, because a button isn't going to be aware of count. It doesn't know that what it's displaying is generally going to be the thing holding async. As I said, for select, like options, this makes sense. This is what's the term? Manufactured example. The differentiator is if the state has to be locked during loading or not. Yes, it's about get. Is pending and latest are about gets, right? During a save action, you might want to prevent further state changes. But here's the thing. Action, latest and is pending are about get. We could implement this a slightly different way, right? And the different way is the generic button way, the way you would generally do a button, which is this: on click and this. This is going to have the exact same UI experience that we've been doing this whole time, where it shows the pending state. And if I unhook the async work, like if we say, hey, there's no async work, it's now not going to show a loading indicator. Same exact scenario where it's based on the load. But now this button is not aware of count. What I did here was the decision of showing the affordance of latest is the parent. The parent goes, hey, I'm going to show latest here. Like, if I didn't show latest here and just showed end, then it's going to continue showing the old value until it finishes. It's still showing the pending state though. So the pending state is coming from inside, but it's not aware of count. Well, it's because in this view, an action is a button is acting more of an action getter, right? The previous example, incrementer, I categorized it as a navigation, right? Because you're basically changing that upstream, like above the async value. You're saying like, it's like I'm going to this page, I'm changing this tab. The tab change itself is an async. It's the work that it generates that is async. Button is generic. It doesn't know how it's going to be used, but it knows that on click, in a sense, is an action. When there's an async load, it needs to show async, otherwise not. So how did I implement button? I created optimistic state. It's false. And then when I click on it, I set updating to true. And this will be basically invisible if it's synchronous because it'll just finish. But if it takes time, it'll stay true until it's finished. And the reason is solid has basically transitions are baked in. You don't need use transition or whatnot. It's essentially you do a change in an effect, or not an effect, you do change in an event. Things that happen in that same event are going to overlap and entangle. And if they take a while, then that optimistic state will hold. And then at the end, it reverts, right? So you're like, in this case, if I'm updating, ... It doesn't matter what the click is. And this is the way you would do a generic button, right? If you thought the affordance belonged to you. See, I'm not sure. I don't build enough UI systems. I don't know if buttons come with their own loading state affordances or if you inject them. To me, this pattern's a little bit weirder. Like, I get the data side. When you have a component that requires data and you say, hey, you say the parent could be responsible for the affordance, but if you're like, no, I'm going to design a generic select list that says, hey, if I don't have, the data is not ready for me to display, or you can't click my button until I have this data, disabled, is pending. That fits very well on the get side. You're basically saying, I can't render this, this isn't enabled. These things are based on the data I get. Whereas this is saying this is process based. When you click this, whatever process that happens out of this, I'm going to have that life cycle. And the reason I'm using this example is you're going to see the difference when I uncomment both buttons. You're going to see a difference between these two. I'm going to put latest end back in, and then I'm going to uncomment this. Now I have both buttons on the page, incrementer and button. And I showed you before that they have the same abilities, kind of like in the abstract, but they actually function differently. And the reason is one is data oriented and one is process oriented. The data oriented one cares about the state of the data. It cares about N. The process oriented one cares about the state of the particular process when you clicked, which means that when I click the data-oriented one, it's pending, but the process-oriented one doesn't update. It updates the numbers because it's showing both of them are running off the latest N, in this one out here, this one internally. But you see there's no pending state on it because for this one, the pending state is based on the data. Is the data updating? And this one, the pending state is based off, are you part of my transition? If I go here and click the process-oriented one, they're both going to have pending states because even though clicking on the process-oriented one means that the process is running, which means it's triggered, yes. But because the data gets updated as part of that process, the data also triggers because is pending is true here. Do you understand the slight difference here? When you're asking about data, that's a universal truth. When you're talking about a specific process, that's tied to the life cycle of the process. And this is the kind of thing which isn't immediately obvious. And I said this is true about async React. It's true about async solid. Svelte isn't quite as mature in this realm yet, or hasn't quite explored the thing that they have optimistic state as part of Svelte kit, but it's not it's not a general purpose concept in terms of the life cycle here, right? What Solid and React are both doing is creating a general everyday solution to this side of the problem. The key is by splitting them, but you start seeing that loading indicators isn't quite the right thing. Is pending is here, and over here is kind of like optimistic state. Question mark? Well, why put a question mark? Because optimistic state is a bridge. Pending is a form of optimistic state. Latest is a form of optimistic state. Categorically, these have the same characteristics, underpinnings. When you actually implement them, optimistic state is pending and latest all use the exact same implementation. They are a form of optimistic state. It's just what's the driver. This one, latest and is pending, are driven off the state itself. They're derived. Whereas optimistic state can be derived. But generally speaking, you're using it as a way of overriding an expectation. If that, I'm not sure I'm making sense of this, but you start having to really think in terms of like, is this a get or is this a post? In terms of what the best pattern is. Is this something that is prohibitive from me rendering? That's a get. Is this something that does something? That's a post. That kind of tells you what the right choice is. And they do collapse a bit, as we've shown up here. You could view, even though this is using optimistic state, it under the get scenario, this is essentially is pending. It's just a process oriented is pending. Right, doing this false to true flicker that we're doing. But generally, like, if it's like in the event handler, it's process oriented. If it's in the data, it's get oriented. And I don't think any of us have done a very good job of teaching people this divide. This is why async React or whatever doesn't sit with people quite right. We're so used to making things process oriented or get oriented on the other side, like that. Like when you're building UI, you're so used to the get UI equals function state, and then on the process side, like you're used to these sequences. People don't know which tool to pick up. And in order to know, you have to actually have a fairly clear model where the separation works. And why this is important is composition, right? If, as I've been trying to show here, if I'm designing a button or something generic, I have to pick the right tool. What's beautiful about both of these designs, assuming you nail the right choice here, is it's completely composable. This button is useful everywhere. Any button that you want with the potential to show an affordance while it's doing work based on what you click, this is it. It doesn't matter what the work is. This is not aware of your work at all. It's just saying, if there's work, I'm going to show a ... or a spinner or whatever. This one's a little bit more specific. This is saying, this is a button that says, it's count here, but if my data that I'm showing, that I'm going to display, is not available, then I'm going to do a ... As I said, this is a weaker example, but you can suddenly see that we have two different classes of like, how should I put it? Like, of composable components that we could be looking at. As I said, I don't know if many components build their loading affordances into them, or they get aggregated, injected. But generally speaking, the promise of the composition here is that you can describe either based on data requirements or based on process requirements in a way that is not aware. As the count kind of hides this, but I mean, this could have been children or could have been like data or whatever. Data is always trickier because data is more specific than process, but you have the ability to do both. What is resetting, updating back to false? Under the hood in Solid, it's the same thing that's causing this when I press this button here, and this doesn't update until the end. The same thing that decides when this is done, when the update is done, is the same thing that decides when the optimistic state is reverted. Basically, whenever you set an optimistic value, that setting happens like when we click the button, we set the optimistic value and we set the normal value because we call increment. So both, we're doing two sets in that event handler, one optimistic, one not. The not is the future. It's saying, I'm going to update this, and when everything settles, this is where it will be. The optimistic is the opposite. It's saying, I'm going to update this right away, and at the end, I'm going to revert it to its base. Now, optimistic is more interesting than that because it doesn't have to just be false. It can be derived from other values. So optimistic can also be its eventual future. You can like predict where value will land and then show that immediately, and then at the end show the actual value. It's the same mechanism, but the core part is calling set on both of them indicate that they're part of this process that's happening. And the way we do that in React is we wrap it in transition call. The way we do that in Solid and Svelte is that it happens within the same synchronous execution, like within the same event. You can always call flash manually if you want to escape out of it or whatnot, but essentially, like if, and that's why this composes, right? You setting update, your on click calling your on click collects all the different state updates you're going to do. This is part of why Solid 2.0 is batching by default. And then it goes, okay, I'm updating this optimistic state, I'm updating this state, traces through the graph, sees the dependencies, sees the load, if it exists, like is it actually preventing us from rendering, makes that decision, and then from that knows when this whole process is done. What is your definition of object handling? It means pretending requests are done before they are is bad, but something immediately and indicates there isn't done. It's speculative. My idea of optimistic is simply speculative ephemeral state. It can serve either as a prediction of the future, or it can serve as in-flight value that just lasts the certain time. But it's basically some sort of ephemeral state. This is what, like, I was talking about. You have two distinct things. This is why I put a question mark beside optimistic, because optimistic state is the bridge between these. If you have, okay, let me see if I can draw this. If you view UI, yeah, sweet, this will work. Yeah, I like this. Yeah. See, this looks almost three-dimensional. That's what I'm going for here. Time. Snapshot A. Should have done this before I copied and pasted it. Snapshot B. Snapshot C. Hopefully you see where I'm going with this. If you view UI, because each snapshot is consistent, it has no knowledge of time. If you view UI as a sequence of snapshots that happen over time, where each one of these snapshots, each one of these is, UI equals function of state, right? Like each one of these is that, right? Each one. But the challenge is, state is a persistent thing. You might change its value, and each snapshot's different. But what if, this is like where I want to like grab like drawings from like Brief History of Time by Stephen Hawking. Like, what if time is warping the snapshot, like the gravity well in the black hole? Like, what if there's like almost like a a force from time that causes temporal warps along parts of the snapshot? What if you need a way of projecting this access into the snapshot somehow? Because they're like, from this is like a whole other dimension, and you need a way of like projecting it, this change, on into the snapshot so that you can see it like a cross-sectional change. So like um sometimes there's going to be these holes. Oh, I didn't mean to stretch it. No, what I wanted to do is grab, no. I'm drawing a cylinder for you guys who aren't quite following what I'm doing. I'm trying to draw a cylinder. Sometimes there's pieces of time linking the snapshots, and in order to, like, if you like time, you view these shapes traveling through the snapshots, you need a way of showing the surface of those on the snapshotted surfaces. That is what optimistic state is. um I don't know if that this is helping anyone. How does opposite state know to revert if it doesn't write any signals? Sorry, just but there's two things. The write itself is a signal. This is a write. So if okay, sure. I mean, let me where is it? Let's remove the load. Now we're not incrementing. Oh, okay. I have to, whatever. Okay, now we're not incrementing. I've moved the async load. It's the same thing as like when I commented out these. All that's going to happen now, nothing's going to happen. There's no dot dot dot, and there's no update because I removed the increment. It never goes to true, like, because it went to true, but then immediately goes to false. It only shows itself if time passes. Like if nothing is load bearing, then there's no transition. Like there's nothing for it to hook into, which means that it just doesn't happen. In the same way that if there's no async here, like I remove the sync, there's no async load, that these just update, and again, they don't show loading. It stays false. I'd have to double check the implementation to see if it like flickers true for a moment, but the effect never runs with true. It never gets to a point where it actually renders the thing with true, because there's no transition. There's nothing happened. It goes and it goes, okay, let's transition. Yeah, there was no transition. Nothing to do here. Does that make sense? I mean, it's async in general. I'm using optimistic state here to like, it doesn't matter what this is. Here we're loading something that takes time. You're thinking, okay, I went to a server, but it could be I don't know. You need to grab a device driver for the cam. I think that's an async API in the web thing. Like it doesn't have to be a server. It's literally anything async. We don't actually care what it is. This is what I was kind of getting at. This is the difference between like the Svelte solution, which is like kind of very Svelte kiddish and tied into like specifically their query command thing. And to be first, I'll start 1.0 is like this too, where basically the optimistic state is a function of like a data fetching solution versus a general solution like this, where optimism is a projection of ephemeral time-based state like into our snapshot time. It doesn't care what the async is. This button literally could do anything async. It could be like go to a server. It could like do some heavy work that you wanted to put on a web worker, and you're like, hey, I don't want to block the main thread. I want to do this calculation in a web worker. Like this button will show an affordance if it detects that there's a real load on the end. We're supposed to use create memo to trigger post requests if we want to use optimistic state. No, create memo is on the get side. Sorry, you're right. I haven't shown this part. This was a generic example in terms of showing how you could generalize these things. But I keep on saying that this is a memo. That or this is a sorry. I keep on saying that this is a navigation because essentially, yeah. Okay. Let's go to the next part of this. I hopefully what I'm talking about here is somewhat clear. Like you can see that optimistic state is sort of like taking something that exists on the time dimension and projecting it onto the snapshots, right? But when we talk about the behavior of these primitives themselves, we have to understand that there are some different nodes here, right? There's like, let's draw a couple nodes. Okay, often there's what I call the trigger. Make it small. Too late. Let's write it out here. Trigger. Or actually, no, let's call this the source. There is the async. Now, sometimes there is no source. Sometimes there's no ID that you're fetching the model for. And then there is the result or whatever. And this can be more nodes. It doesn't have to necessarily be an effect. But essentially, if you assume in a scenario like this that the update comes into the source, right? So this is like trigger update. And then there's this arrow, which is upstream of async. And then we hit our actual async, and then we get this arrow, which is downstream of async. This is the general get cycle, right? Like a navigation. Generally, and it's also the refresh cycle too. Like when you remember earlier, we were looking at this, and that we were saying like state as an input, or sorry, state as an output. Sorry, but like when you move from post to get, usually there's a source that triggers upstream async. So this is usually a setter or even the refresh function in solid. There's some mechanism that pushes to the async, and then there's down to async. And these are important zones because they have different implications. The whole change, like this whole process here, from start to end, and I don't want to use the word process because we're loading it here. I haven't come up with a better term for it, unfortunately. It's the transaction. Actually, what did Svelte call this? I actually went Svelte 5 await expressions. What did they say? Blah blah blah. Synchronized updates. When an await expression depends on a protected piece of state, changes to that state will not be reflected in the UI until the asynchronous work is completed. So the UI, in other words, yeah. So they, instead of calling them transitions, Svelte calls this synchronized, right? Okay, sure. It means that this whole thing only appears together. The source that updates, the async that resolves, downstream the result. These are all become one unit. This is the cutting edge of the discussion. We're not there yet in our talking right now, but we will talk there in a minute. Yeah, transition, I hate it as a term because people use it for animations and stuff. Transaction is closer, but it's not, it doesn't have the same guarantees as transactions because it moves towards an eventual feature. These things don't exactly roll back. And the entangle. This is a place that has terrible terminology. I really don't want to teach people the word transition, even though it's React's term. But my point is, this is the get side, right? Right. So this is like the anatomy of even initially the source is set or we trigger it later, right? This is basically the get side. And if you look, there are parallels between this, unsurprisingly, and earlier when we were doing state projection of state UI. Like this is, sorry, I didn't stop there long enough. This diagram, unsurprisingly, is similar to this thing because this is our UI as a function of state in an async world. How many times am I going to draw this diagram, right? And you can see it because it's source, which is a state, async, which is derived state, and then the result or effects or whatever coming out of it. It's the same graph. But the reason that we're looking at this here is that because this came out of that like create memo question, right? We're supposed to use trigger post request, right? No, the post side. So like when we zoom out, which is like here, that sits on top. On a basic level, you could, like in a microcosm, you could view it as like a setter, right? Like this arrow here maybe doesn't, it belongs up here. It's outside, right? At the most basic level, it's a setter. But when we do something more substantial, like we want to save before we get, like a navigation is simple. A navigation, there is no, like this part is synchronous. But when this part is not synchronous, we need a whole other way of handling it, which is what actions are. See, optimism isn't limited to actions. Optimism is just a projection of time into our get access here, right? But actions, and I guess it's time to pull out an action example, for example. What's an example that has actions do I have any simple action examples? Most of my examples, this has got to be our navigation, right? This is funny. This isn't even an act. This is a navigation example that has a pseudo action baked in. So I want to go here first before I get to actual action APIs. I don't know if people have seen this one a ton. This is the original demo that Dev did, where it's a counter that fetches something and then randomly errors on you. But the randomly errors is actually the important part here because I've had to think about how I approach the error for a while now, because what I love about this example is it shows like the the way that you can, define the graph here, have your async, and not really worry about the loading state until you get to the message. Like when we load the page, we can show everything, and then you just have the loading state down there, even though, stuff's up here. This example was originally to show that you could take count, derive it, uppercase it, do a bunch of stuff to it, and none of this actually triggers async until you actually, again, have your sync down here, which is bounded by this loading boundary. But what happens when we error? Error was a fun one for me to figure out what we want to do here, because there's two ways to get out of an error. There's the retry button, but you can also have the increment button. So you can just click past it. Now, the retry button is calling some reset mechanism that we built into error boundaries, which is smarter than we had in 1.0, because this reset mechanism actually walks up the graph to the actual error, and when it gets to an async source, it actually tries to retry that async source. So we actually have error, like this error boundary, again, composition. It can be down low where you're using this stuff, because error is a question of, can I render this UI? It's not about process. It's about, can this UI be rendered? It's the same reason why create effect here has an error console here, because our argument is that create effect isn't about rendering. Render effects are, like things we use in the JSX. So it's perfectly fine if you want to handle the errors yourself and not trigger an error boundary, because this doesn't impact can I render. Just another sort of thing, because this error, and it's above the error boundary, and it didn't kill our page. It's because user effects, normal effects, don't participate in error boundaries in Solid 2.0. It seems kind of weird, but error boundaries are, again, when you follow this classification, error boundaries are a get concern. They're boundaries, they're part of this, and effects aren't a get concern. Side effects. Rendering is, so because of UI, but general side effects are not. So back to this example. Why is this example interesting? Well, this example is interesting because when you click the button, you don't want it just to stay there, because we're in a transition, right? Like if the button was always there, you click it, you could just keep on clicking it over and over again. That doesn't make sense. You want to click it and then say disable it or make it disappear or give some kind of indicator that it's retrying. So what I did was I wrapped the button in a show. And so like, it's like, if I'm not resetting this, but how do you know you're resetting? Well, this is a perfect use of optimistic state, because it's not just like, look, if I asked if I was pending instead of resetting, look, is pending count? Let's look what happens. If I click this button, is that what I want it to happen? So I need to get to an error again. It's weird though, because it's actually not, it's entangling and not showing yeah, what I was trying to show was this. Sorry, I was clicking the wrong button, not seeing the same thing. If I use is pending, the problem is when I click to go to the next thing, because it's based on the data, it's actually going to show that it's retrying, but we're not retrying. We're actually going up to 6, because from a data perspective, we are incrementing the number. We are changing. That is pending, but it's not retrying. Retrying is the process. So it's not based on data. So you don't actually want, you actually want to tag the process, which is why we're using optimistic state. It's the same as my example before I was showing like the different buttons lighting up, when we were doing the divide, whereas like both buttons versus one button, this whole thing, like this one does both, this one only does one. This is a case where you want the one. You're like saying, look, I'm doing the reset here, right? I'm resetting. Give me an error. Okay, I'm resetting here, or I'm retrying. I want to be retried. But when I click the button and leaving, I don't want it to be retrying. It's One error again. There we go. Now when I click it, this one just grays it out and disables it. See, disabled if it's pending count versus resetting. These are two distinct affordances here with a very subtle difference. Whether or not the button is enabled here is based on whether the data is currently loading, but whether we are resetting is specific to this process, which means it gets its own optimistic state, right? How you handle the affordances, whether you hide or show messages, is completely up to you. That part isn't important. It's understanding that there is a difference between, am I asking whether I can do the process because the data is available, or is my process currently running? As I said, these are the kind of questions you got to start thinking about here. I can see how there's a bit of like a mentality change, which makes things kind of hard because you're like, how do I make the right choice? And kind of working into those patterns. But on the flip side, once you have the system in place and you use these things, you don't have to worry about race conditions or any of the other weird side effects that happen with async, where you have writing to the loading state and having to keep a loading counter to make sure that like, oh, this thing's loading, but this is not. Should we show loading? All those weird conditionals, like if this is loading or this is loading, these kind of patterns generally just naturally fall out of the system when you go look. Resetting is a process. Because at one point I was like, maybe we should add like a resetting flag here, right? So you could like check if you're resetting specifically. But then I was like, it's a choice. What if I don't want to use optimistic? What if I want an optimistic store? What if this is part of some other primitive? I don't want to make that decision for you. You can add optimistic state to any process as a way of giving an indicator that it's in flight. And you can model it however you want. I don't have to make that decision for you in the component design. It's pretty easy. You just go, hey, I've decided that I'm making a process that resets. Am I resetting or am I not? Create the optimistic state, tie it into the action. Now we're good to go. In a sense, reset, just like refresh, is an action, or set. These are just even though they take slightly different forms, they are ultimately just a reactive retriggering, like we're showing over here. They're just another way of triggering this get side of things. So this example is still synchronous. It's still arguably navigation-ish. There is a process here. But if you look at, like, we are doing a thing, we are resetting the error boundary. That is a process that triggers get. But the process up front is not async. Now, if the process up front is async, we do need another tool, which are actions. But generally speaking, it's just an extension of this pattern. Is it about the data, or is it about the process? Framework should have debouncing built in to make it low friction as a normal ways of doing forms without it. I'm torn on that. Yes and no. There's different types of like throttling versus like debouncing, and like a classic example of this, like the Netflix search bar or whatever, like the classic kind of thing. And one argument is like you should only do the searches at a certain interval, but that can actually slow down the search results. So what ultimately what happened with Netflix and most of these UIs is there might be some throttling happening somewhere on the back end or some places like there is a secondary concern, but generally what you try and do is eagerly fetch the results as fast as you can and then kind of throttle on the way back out. Which is not good for API limits, but it means that the end user's never waiting. You just want to make sure that you're not like jittering them like crazy. You only show them consistent UI. And in a sense, that's what these async systems that react and like solid and all these built in is like when we were on the divide example and like hitting like 10, these aren't being debounced exactly, but we're not thrashing on you, and you get the results as soon as they're done. This should be built into every framework. Debouncing and throttling is sort of a choice. I think having tools available, like we have solid primitives over that, like they're core enough that I think it's valuable to have them. But generally, it's a time, it's a timing concern, which means where does it belong on our graph? It's not part of this, it's part of this, right? Which means that if we want to have throttling built in, it should be part of this side of the picture, which some like maybe for the first time this is actually an option. Oh, what do we got here? Create memo, await debounce 100, return. Yeah, I mean that's throttling on load. Um, yeah, you can you can always make a sequence of awaits. Um, yeah, I mean, the reason I'm bringing this up is this was the exact kind of argument that like this was the thing that like React when they were designing this were trying to express. And again, we've done a very bad side on the framework side here that like there are affordance ways to give affordances like this way you can keep on typing. That's what you're seeing here. The numbers incrementing means you can keep on typing. Um, and in a sense, I am throttling. There's a starvation question that has kind of gone back and forth, and that's probably maybe worth considering. But it's just like I think the front loaded side of it needs to be a choice. I think the back loaded side is a consistency thing, so it fits in the framework zone. But what I do want to get to is looking at actual actions, and I think what's the simplest version that has actual actions? Probably optimistic data or optimistic UI. Um, Probably optimistic UI. Yeah, this one is the simplest version because these are examples now where you actually do something async before um you you trigger the refresh, because as I mentioned, refresh like sets thing is this part of the equation. What does the post part look like? Well, generally it's a sequence, so this is a place where you would want async await, except async await doesn't carry context. We can't combine it in our synchronized thing, because when what we want to do here is actually when we have actions, we want to extend this synchronized envelope to not just the get, but to include the post as well, because otherwise you get other race conditions. Um, and this is a big part of kind of unifying the solution. So like this is why you can't keep the context in JavaScript. We have generator functions. There are you could do something where you could like restore the context like after the await, so you could like have an async await and then call restore yourself, um, or call action again. Like in React, it goes like transition and then you nest transitions to restore it. I've mentioned this before. It's so hard. People forget to do it all the time, and it's even writers. I'm not picking on Ricky here. I did it myself a couple times. The first like 3 demos of React Async, this was the exact mistake that Ricky made on stage of forgetting to restore, or like the context for the transitions and the actions, and it kills me every time we saw it. Happened on my stream, happened at a talk, happened on Jason's stream. I just caved and I'm like, we don't have the async context yet. We're gonna use generators. Generators are cool because you can do a lot of cool stuff. You can make like generator helpers, like which that are composable. You know, you're talking about wanting debounce. What if you want retry? What if like, because what you can do with generators, it's composed generators, and this is what I was talking about, it being a completely different API. You can do stuff like I'm just going to open a playground here. Let's refresh, where you can basically build let's say this is our whatever, this is our action. I don't really care. See, I want async function. This could be the other reason I didn't like threading is because I like keeping the whatever. I like keeping the arguments transparent. Like when remove to do takes an ID, like we don't have to like overload the arguments. Like what you see is what you get. This creates an action that takes ID, which returns a promise. My what's cool with generators though, like, is you can create stuff like result error equals yield star, which composes other generators, and be like try catch, fetch something. We haven't implemented try catch here, but my point is you can actually I guess I didn't need it to be async after all. You can actually kind of compose other behavior, so you can make like a common helper that also can feed into the generator, and then now like we can take a promise and like get a nice error thing. We can try catch with retries. We can, you know, I think there's a whole slew of primitives and basics around like working with sequences. I think I know stuff like effect TS works a lot with sequences, but I think there's like a whole, we're not shipping anything core with solid other than the support for generators and async generators. But like, if you want to design sequences, there are tools for that where you can like create an action that's like do this, and then like if error, do something else, and then like, you know, take the results and, you know, grab something, you know, do something else. Like what's beautiful about it, like async await, is you can go be like do this, like do this. I was actually, I don't know if I have the example anywhere. I was actually using actions to just like do silly stuff like yield new promise, set response, set timeout, because it doesn't really matter what the async is. Like you could just like bake it in that say wait 2 seconds. So you could do something like show message, like some optimistic state, like success, right? And then yield the promise for 2 seconds, and then it like auto will hide because the transition will wrap out. You know what I mean? Like you can basically use ephemeral state as a way of like showing toasts, right? Like, and use the fact that these are state mechanisms, so they can like dedupe, they can manage like concurrency, and then just not have to worry about the wiring of like timing and collisions, because the action, you know, like an animation is basically like a sequence. So like there's a lot of potential in this realm that I haven't really even touched on. The important thing is to understand that it's a different shape. This is not about reactivity in a sense. Your way of tapping into the reactivity is either by setting specific state that will, end up at the end of your synchronization transition or whatever you want to call it, showing, and also, interlacing optimistic state or ephemeral state essentially throughout the process to give people the affordances they need while the process is running. That what's cool about this is like out here you made like a message, show message as some like create optimistic, right? Create optimistic. So this is part of like, and it's undefined initially or whatever. This is part of like your UI. So your UI in here somewhere you have like, show when message. So it's very declarative in how you're setting it up. So you're following typical UI following rules, but the timing isn't your concern. You've isolated the time from that. Like this will just be like, look, when there's an optimistic message, show it. This kind of split mentality, I think, is incredibly powerful because this has always been the problem. Like you end up with these imperative APIs to show dialogues. You know what I mean? Like you're like I think everyone's been there where you're like show dialogue or whatever, and then you're managing the life cycles of these things, and this allows us to basically turn it back into declarative state. Maybe this message is actually a portal. I don't know. Like this is sort of what I'm trying to show with this. These aren't just data fetching concerns. These are async concerns, right? You can sequence actions. You can, when they're in a single action, they flow together. But then you can also like have actions because their promises await other actions and create actions themselves are sequences, and you can do sequences of actions if you want to like handle them as separate synchronizations or transitions. So they both compose from the perspective of creating one large envelope, and you can also chain the envelopes together if you want to kind of like isolate the separate processes. This is like a whole different place that almost is worth, spending some time in the future to explore and like look at what this means in practice. But what I'm getting at is the separation allows the composition. Right? These are base primitives that don't care, like one side just cares about consistency, doesn't care when it happens. The other side only cares about the ability to signal stuff. It doesn't care about what it does. And you keep that isolation of like process versus pull or get, post versus get, and you can build each piece up independently. You can already see that kind of like how this constructs. You have found straight for toast doesn't really make sense to me. Well, the problem is you're left managing the state. Like it's not even state. Like there's no representation in a UI framework that like like putting it into a show. Like obviously you could just have a third party library that just handles it and then you like defer it outside the framework. I think that's perfectly fine too. Like specific on the toast case. But what I'm getting at is categorically, it's always been a challenge where you have these life cycle things threading through like what things that have no sense of time. This way, time, this and this and this, simple rule. And the ephemeralness just kind of takes care of itself. Remix 3 at home, yeah. Well, the challenge, yeah, this is Remix 3 without throwing out like everything. Like the problem is this keeps your state structured. The challenge in a system like Remix 3 is you're not really deriving stuff. You're just like adding more and more state variables. The way Remix 3 solves the problem in a sense is it goes this is too rigid, or sorry, this is too rigid, and you're gonna do this garbage anyways. So why don't you do a little bit of this? And in a sense, I've taken the opposite tact. I'm like, no, we need to get rid of this stuff. Let's pull it, streamline it, and then give this its own special place. Like, in a sense, there's like a shallow comparison to something like Remix 3, where you can be like, okay, I'm setting message, I'm calling loading, I'm set loading, do the thing, set loading false. That was essentially what Remix was doing in those demos. But that works really good when it's process based. It doesn't work as well when it's data based, which is what I was kind of getting at. Because the reason this demo is so good in solid is because when I add another drop down here, each select list is responsible for its own pending state. Like cities, cities, cities. You notice how this thing only cares about cities, even though what's triggering it is actually changing the state. So if you add countries, and then this is depending, this stuff will all be based on state. It doesn't have to worry about the triggers anymore. The challenge was something, and I actually challenged Ryan Florence. I'm like, when Remix 3 is settled, I want to see the 3-tier country selector example, where you now have to worry about multiple loading states, and it's not the drop down itself that's triggering it. It's a different drop down. Like, changing this drop down is triggering that one's pending loading state. It's like cascading. That kind of produces pretty terrible spaghetti, at least hypothetically what I'm thinking at. If your event handlers all start needing to worry about the state of other UI things, like you're basically, this is why you saw that big argument, not big argument, but like Rick and the React guys are going like Remix, like to them, they just see this and like, are you crazy? Who wants this back? Remix is more like, we're going to be is more kind of like, we're structured this. They're like, look, you guys are trying to be too rigid, forcing things in a weird way that doesn't make sense. We're just going to kind of like make it easier to do this. That's the kind of reality. But like, when you look at the craziness here, I can understand why the React guys are like, this is not the way. This design that we're working on Solid 2 is basically the React design. People are always critical on React and that stuff. I don't have, I think their design perspective is good. The tricky part for them often is implementation. And I think thanks to Svelte getting us in there and not having as big of a long history here, and just the power of signals in general, we have a unique ability to not just have a better solution in terms of implementation, but also in terms of like structure architecturally, right? The way the composition works is a lot more fluid than forcing every UI library to put use transition into their event handlers, and then now what do you have on click or click action and like propagating it through that way. This is just kind of inherent to the system, but that's not really React's fault. It's just that I think if they started today, they would have done that aspect similar to Solid. It's just they can't. Yield basically spells the same way as await. I think yield without star is a weird one as it reaches the real value of 0 yeah. Yeah, the only challenge here is that I would love a world where we could just go wait, but we aren't in that world. It doesn't, right? It's just async context. We've been waiting for 5 years, and we might be waiting for another 5 years. Yeah, this isn't saying it's better than async context. I'm saying this is what async context or future solutions will give us. It just, your options are either use generators or like have a really ugly foot gun full API. Right now, there isn't really a middle ground. Something from the server, yeah. But what all I'm saying is like, this is this little example where I'm being a little cute is I'm showing the toast for 2 seconds. The server is what's doing the work and saying, hey, okay, success, you know, show the toast, like the typical action. I was just being cute and being like, well, we can also show the toast for 2 seconds. We can make a confetti explosion go for 5 seconds, then show the toast. Like you could, I'm saying the sequencing continues beyond the server interaction part. You can actually like create a whole party of animations. That's all I'm saying. I don't know what people can do this. This is probably maybe not realistic. I'm not. It's that the whole thing is an async process. It doesn't matter what that async is. I really want to emphasize it's just not just the server. Okay, so um, yeah, my hope out of all of this is that when we start talking about this stuff, we can get to a point where we can come to the right terms. Transition being an awkward term is our first problem, right? We need a better name for it. Our other challenge here is that like this whole post versus get, or the process versus like display propagation, isn't the way people think a lot now. I think this model is coherent. I think, like as I said, it's a way of representing time. It's both a way of getting time back into our derived equation and representing the like ephemeral bits of process as projecting onto that plane, and then giving specific tools to handle that. But it's not always obvious to people, I think, when something is data driven or when something is process driven. And this is where the whole composition question comes in, right? Because when you create basic level components, you kind of have to make that call. And I guess the answer is, when in doubt, make it process oriented. As we saw like in our divide example, um, like for button, it's but like it's very specific places where you're going to want is pending or latest. These in reusable components, they're going to be when you're disabling buttons. It's all about like, can I render this? I'm pretty much delegating is pending to like, do I have what I need to render, and do I want and latest for, or do I want to enable tearing? Like most inputs, you don't want someone to type into an input, for example. Our native inputs don't have this problem because they actually tear by default. Just the way Solid works, we don't have like as like complete controlled inputs. They're kind of sort of uncontrolled. Um, but but if you're building wrappers, then you are gonna inevitably ask this question. Like if you're not using the built-ins, your questions on are like, when someone types, for example, you don't want to like, if they trigger async, you don't want them to like not be able to type any more letters. You want them to be able to complete typing. So you're going to want like latest to show the update. This is why when I click it, it goes to 3741 whatever immediately. And you're going to want a way to say like, if I depend on this, being there, then I can do that. But outside of that, a lot of things are process based. Now I don't know if generic components have a lot of this listed. I'm not experienced enough to know that it, like, if I go pull up like ChatCN or Cobalt or something, Cobalt's solid, yeah, it's our UI library, and I look at some basic components here. Alert. Do any of these have baked in affordances like button? My guess is button does not have baked in for thing like this. It has disable, and data is disabled. Yeah. And then it handles, yeah. Which means that you're the one consuming it who feeds that in. So you make the decision. It's not apparent. Like I think a lot of times, a lot of these affordance decisions don't end up in the most low level thing. They start reflecting your, like affordances are kind of a designer's choice. They're your system. I think if you go the next level, like above Cobalt, like your eBay, and you have a specific design system with specific design system rules, then they will come in. So like lowest level components, like generic, anyone can like build their component libraries on top of those. Probably aren't going to use this a ton, except for like managing like tearing aspects, things related to accessibility in terms of function. I think that like a lot of them will just expose it through like a disabled, like is there select list select will probably have it disabled as well. Trigger context arrow, default value. Okay, so these have error affordances for validation state. Okay, that's cool. Placeholder. You could argue that frameworks didn't have the tools to give people, and this will be like a new expansion on it. But I'm not sure. We'll kind of see how it floats out. My guess is that this stuff might sit like not quite application code, but like basically the reusable parts of your application code. A lot of this sits because in practice, what ends up happening, I think, is there's going to be a lot less is pending than people think. People are stoked when they see these demos and it is pending because they understand what it represents. It's incredible. But in reality, loading is going to handle most of the initial load. You're going to have your affordances. And then when you go and update something, you're going to want to associate with that specific process. You don't want like a different part of the page lighting up because it touches the same data. You're going to want to be like, look, I am doing, in most cases, I'm going to do this process. And while it's doing this process, I'm going to show an indicator, which means loading indicators are often going to be optimistic state instead of it's pending. And you can kind of see a little bit why when we even look at the simple optimistic UI example. Because an update is often something to the server and then a refresh. It's not until we do the refresh here that we know that the to-dos are updating. So this is when loading, this is when is pending starts. Is pending doesn't start here, like before we go to the server. It doesn't even know what data it's dealing with, right? Like it's here, it says pending, but that's too late. You want to capture the process. You want to say, while I'm adding to do something. You want it to last through the refresh so that when you have multiple things coming in that they don't like mangle each other. But you don't actually know that to-dos is impacted until this comes back. Now, with optimistic UI, we can kind of guess at it essentially, because like if I go in here and we have some optimistic UI, when we add to-dos, we're adding optimistic UI here. Now, this is actually just adding it to the process, right? We add the to-do and show it in the list. It's not that in here we know that the to-dos are loading. We are actually looking for added to do our affordances. There's no is pending in this example at all, because it's process oriented, and that's sort of what I'm getting at. This is actually probably leading to the biggest point of trying to determine how these pieces interact, because kind of I'd say one of the last open questions we have on 2.0 right now is whether the optimistic state itself should be viewed as pending, right? So let me just look at comments here for a second before I elaborate. The case for having buttons is that you automatically get some affordance automatically instead of the UI just holding. Yeah, I'm just saying historically, I don't know if people have ever done that, but we have precedents for this, right? What I mean by that is, actually, no, we don't have precedents for this, do we? When you click a button, you see the focus state, you see the click state, but you don't actually see the I'm processing state. Yeah, you know what I mean? The native buttons don't have, like, the affordance responsibility for a button purely is the fact that was I clicked, not any connection to the work that's downstream. I know a lot of people like picturing these systems, but I think there might be still too many variations and variables for the most generic systems to actually bake that in. I get why people might think they want this. I'm just not sure that they actually do. Anyway, um, back to hey, sorry, just clear my throat. Back to this for a second, because what I want to talk about here is this upstream versus downstream is important because optimism has some. We should talk about optimism for a minute because it has some impact. Because let me. I'm gonna copy part of this. Yeah, let's play over here with this. Because while we're in the process of doing our transition, we know that it's pending is going to flag true for all this. But what's interesting is how do our optimistic nodes fit into this thing? Let's say if we add our we lost our source node. Let's do some color coding. Source nodes are going to be green. Async nodes are going to be blue. No. Red. Let's keep async red. Result is going to be brown. Okay. So there's an interesting question of optimism usually snags itself in, like, you don't latest, you might use latest on the source here, like up here is where you might tap latest because you're like, I want to see the source right away. But you can't, if you try and put latest down here downstream of async, it can't show anything until the async loads. There are cases where you'll want that when you chain async, where you, but latest doesn't become like doesn't show up after async until async is complete, because before that it has to be the previous value. There's nothing to show. So, but if we're talking about optimism in general, usually it sneaks in down here, because what you'll do is you'll trigger some async and then you'll sneak in an optimistic node with your prediction. Like, so far we've been using optimistic as like yes, no. a bit, but if you look at the to-do example here, this is a little bit more subtle. It's not just yes, no, it's this optimistic state. Because this one's still not good because it's still yes, no. It's an empty array, and then we add optimism. It's not, it's still separate. Let's use completed. Yeah, this is a better example. Okay, so I'm gonna put it here. Now, completed, as soon as even though it's taking 2 seconds to save, as soon as I click it, it's showing it disappear. And then it resolves. What's different is with completed, our optimistic state is derived from props to do completed. We set the new value during our toggle change, right? We set our new optimistic value, but it doesn't revert in this case, because hopefully when it comes back from the server and rederives, it gets the updated value. This is the common case for optimistic updates, right? Like if we didn't have this and we did this, when I check it, the checkbox is tearing anyways because I told you our built-ins are tearing. But look at when this line crosses out. Now it does when it's finished. Whereas if we do this, now it crosses out immediately. Right? So like the classic use here of optimistic state, for actually optimistic state, not just for like saying like am I loading or pending, is actually deriving it from the source that will eventually update and predictively setting the value. And that's basically what I'm showing in the diagram here, because what we're going to do here in this arrow, well, it's blue right now. We'll figure out what that means. Downstream of optimism. Doesn't that sound nice? Wait, optimistic. There's an interesting thing that happens here, because when you become downstream of optimistic instead of downstream of async, you actually update immediately, which means that this is you'll observe different things between something that's like this and something that's like this, right? I'll put it there so it's on the same level. But what's interesting here, and something that we had to kind of work through as we were working through the design, was what happens if like this is kind of obvious that this holds, whereas this like breaks. What happens if we throw another wrinkle in here? And do this. Now, I for a long time that I did not like this pattern very much, but this is a potential thing. What if the optimism lets us optimistically fetch more data? Well, what we have here then is no longer a clear like this whole like when you look at this model, you can kind of go like, okay, I get it. This transparent. This part holds, and then like this part doesn't hold. Like can I make it call it the blue? No, blue. Keep it transparent. right? You can kind of like see two zones. Like in your head, you're like, okay, well, this is easy. And you might be like, if there's multiple of these all go right away, and then this part holds. So it's almost like escape the transition. But it gets a lot more complicated when this happens, because now, sure, this holds. I need one more. But what does this do? Well, the answer is it holds as well, but only as long as this async is relevant. So you almost get like sub transitions. And this cascade and the potential of these graphs merging has led to a very complicated optimistic lane solution where you actually have transitions broken into multiple different update streams, which obviously I doubt anyone really wants to get into the mechanics of that on stream right now. Okay, you want to see an example of this? Sure. Yeah, this might not be visually obvious to people. So let me show an example. What's it called? Not nested fetching. Optimistic fetching. Okay. This example is interesting because there's an action. When they call it handle select. This is actually saving. Like when we change this, we're actually going to say that we're saving something on the user's profile, right? So we're updating their user preferences with a new category, and then ultimately we have to refresh the user's category, right? But first we set it optimistically, right? The problem with this example, which makes it such a pain in the ass, is oh, I haven't updated this one. How did I miss that? Interesting. Did I not update? Oh, it is on 16. Okay, whatever. Interesting. Yeah. What's interesting about this one is by changing the category, you also have to fetch the new data here, right? So our category is actually based on the optimistic category. So because we don't want to wait for the save to happen to fetch the data for the next thing. So it's actually driving the current selected value is the optimistic value that you're setting here. And because you want to show it right away, you want it to tear, right? You want this to immediately go to news. Actually, to be fair, this is actually just the drop down. Like it'd be weird if you did a drop down and the value didn't change. This is just the built-in drop down thing. So this part's not that important. This would have probably worked either way. But the important part is that our category section is based on the optimistic category instead of the waiting for the save. And then in here, it fetches its own category details and shows it. If we didn't wait, this would tear, right? It would show finance right away because it's optimistic, and it wouldn't wait for the data to show up. See, this way, it actually waits there. But you're wondering, why is this interesting case? Because the stupid update profile thing takes 2 seconds. So the whole update of this section here happens in half a second. This is still saving in the background. So it independently flushed it, even though the whole transition isn't done. You can't visibly see that, but it's an important distinction because this is it's actually 2 seconds to update the profile and then another half a second to actually get the latest. Both of these things happen. And what makes this challenging is, which might not be obvious to people, is since the data is done, Like we do this, we switch to news. That's optimistic. This completes 2 seconds later, and and then it triggers refresh, and then it matches, so it doesn't have to do any more work. But what's interesting is this example is pending. Um, and you're like, but if category data here, or sorry, category name, which is coming from optimistic category, is derived from user category, which is getting refreshed, wouldn't the pending travel through? And the answer is no. It's because optimistic overrides consider themselves a source of truth. When you say, hey, I've got the value, we're going to trust you that you have the value. And in a sense, it's no longer pending. You have a projection of the value, which is why we have the ability that when it finishes, the fact that this refresh of the base category happens later doesn't cause it to flicker into pending again. This was working on this. This was the bug. There was two problems originally. We didn't wait and it split. We didn't make sub transitions. And the second problem was it would change, stop, and then when refresh, like after the 2 seconds when it goes to refresh, it would cause the whole page to go pending again, which doesn't make sense. So you start seeing that the interaction between these pieces is not. There's some complexity that comes here. Part of it is sub-holding. Other part of it is if other updates come in from the top here as part of this transition, how do we keep this isolated? And the answer was like, there's a third thing that I didn't explain yet, but there's a third scenario that's complicated is you also want, if the thing's wrong, to refetch the data right away and not wait till the whole transition's complete. Because otherwise you get into this, like you basically have this data waiting on some other async that might be triggered over here. And you want to parallelize stuff as much as possible. So we had to basically create a system where optimism is both not a completely separate transition. It can read from its parents' updated values as they become available, but also be able to isolate its own updates. What does this have to do with composition? Well, that's what this is all building up to. Does it refetch the old value if the update fails? Yes. Well, actually, let's see what happens when the update fails. This is the right kind of question to ask in this example. So update fails. Presumably this has error handling, which it doesn't. You would say refresh user category, which would, yes. Generally, if you tell it to refresh user category, then it would refresh. It depends on how your error handling happens here. Let me give you a more concrete example, not of the optimistic refailure, but if we look at the optimistic data with the Affordances example here for to-dos, I actually have error handling in it. And in my case, yes, I sit on error to still refresh. It's a choice. You could also say not refresh, but if you don't refresh, if states moved on, it's kind of hard. You would have refreshed anyways if it has succeeded. I know in essentially like it's wasted work. So in some scenarios, you could argue that you don't need to do the refresh. You could just do a manual patch of the data if it's available. You have options here. It's basically how you write your action. And the way that action was written, if I try catch the thing and to put refresh, then yes, it would refetch if it fails. The other thing is I don't have this example shortcutted here. There's an example where the predictions were wrong based on like shipping things. Like it's some crazy example. Worked for, I talked about this on a previous stream, but like worked for almost a month to kind of iron out those details to make sure that these things can compose properly and consistently. But I think one of the biggest challenges we've been having recently is kind of down to the base, and you can see it right here, is if you have a basic button or something that's depending on is pending, and you have these optimistic updates blocking that stream, if they're part of the same primitive, there's a choice here. Now, you could argue that the thing isn't, in a basic case, it isn't pending because you gave it the optimistic value. You can work on it right away, right? And I think that's fair. But when you have stores and optimistic stores, which can be more fractured, it's a little bit harder to see like how like similar or different data in the same kind of zone. So we're still kind of working. I think this is going to be like the last little piece here, is working through the details of what that means or looks like. Sorry, I'm just opening Discord here for a second. So, because I think I actually have an example in Discord that I might want to kind of look at here, because it is a real kind of bug, so to speak. Let me. Because like our to-dos with affordances example works really well, because what we do is whenever we perform an action, when we set our optimistic data, we tell which rows are impacted. We say, hey, we're going to say pending true on that row. So when I add a row or update a row, we're going to actually add data to the row. And because this is an optimistic store, when the real data comes in, the pending will just disappear. So then I can do silly stuff like turn this green. What's going on? Is the whole thing freezing? What did I do? Have I not updated this one yet? It's weird. I thought I tested this one yesterday. That's interesting. Wasn't this working earlier? It literally got past loading earlier. Oh, I hadn't updated this so long that it's the same problem we had in the other ones. I'm gonna have to go through and make sure we 4 releases back, we returned to the key distinction. Okay, there we go. Thank God. Okay, so yeah, like see, that one failed. It turned to red. But the fact that the reason I can turn green while it's like working, you can succeed. Okay, well, or like when I add stuff, the failure rate on here is pretty high. Is just a matter that I mark the specific row. This is the pattern to use with optimistic stores, but it's interesting when you have stores that could be involved in multiple different processes, and some view it as a data thing and some view it as a self-management thing. Like this example is interesting, where essentially, again, made to be contrived, but you have 2 tabs. When you change, it disables a drop down 5 seconds until it completes. Click here, disables this drop down until it completes. So this is like the loading indicator while it's moving over. But if this ID is part of the same store, and then you're like doing optimistic overrides while it's changing, suddenly this becomes unlocked because the optimistic override is blocking the pending state. Similarly, before we nailed down this behavior when it was like half and half, Brenly wrote an article, how my mental model of its pending changed, and it depended on a kind of partially implemented, like this was an accident. I didn't actually intend for this behavior, but it was kind of like half working, and we had to make a decision to go hard one way or hard the other way, and we went hard the other way away from this, but this is still up for discussion. Because optimistic state specifically, this is a great article to read if anyone's interested in, even though it may or may not be outdated. Because optimistic state was flagging the as pending indicator, he could basically use it to instead of adding like pending to each row, like I was showing in the to-do example, he could just like ask about the specific thing. Like he could go like, is pending books.length or books title, and the optimistic state's existence alone would tell him that it's pending. But he ended up using this kind of interesting hack, where where was it? Yeah, I think it's. Does this use latest with it pending? Let me see if I can find it. Yeah, because latest with pending would hide the refresh. See, the challenge with this whole system, and this is kind of like the last design point, is and you can see this when looking at a to-do example, for example, or any of these really. There's always the mutation. Like here's the optimistic state, here's the mutation, and then there's the refresh. But until the refresh happens, the only indicator that we have that something's changing is the optimistic state. Now, if we take care of it ourselves by like adding pending states and stuff, this works well. But is pending doesn't work until the refresh happens, which means it's like too late. It's not tied. So as I said, usually you say it's optimistic, tie it to the process. But you can see how does this compose well? You know, that's the question. You can see in this example where two people made two separate things, one that depended on pending on one part of a store and something else that, you know, is kind of managing its own optimistic state, and they're kind of butting up against each other. So this is kind of still like an open design question where we're still iterating on. It's funny that like this is so fringe in a sense that like every single example that I've shown on stream to date still works without making a decision like that. And we're getting to a point where we're like really trying to contrive stuff. But these kind of details matter when you want to make, you know, something that works independently without being aware of the other pieces. So this is the kind of questions, like it's not just a matter of us getting our mental model around the fact that there's a clear distinction between process and propagation, but that there are real implications of how these things layer on top of each other. My hope with these kind of things is that once we land on which way to go, and I think both extremes actually have an argument for them, that you're never going to actually probably think about them again. It'll just be kind of intuitive. Once you choose the right thing, like this is process oriented or this is data oriented, it'll do the right thing. But there is definitely a little complexity here to consider. Sorry, I missed this a while back. What is the optimum part? I didn't quite understand. I think you were talking, you fetch something that makes the current div more opaque and reset the value if we messed up in theory. Or yeah, okay, sorry. Yeah, this is back to this example, I think. Optimistic fetching. What's optimistic about this is actually, if I'm writing the right example, is actually the category you choose itself, which actually means that we're feeding the category choice all the way through to the actual data fetching. It's actually trying to fetch data before it's saved the data, like save the choice. If we're talking about the same example, hopefully I am. I'm sorry I missed that question earlier. Like it's derived from the user's saved category in the database. Essentially, you can pretend this is a saved category in the database. The optimistic state is it's layered on top, and you're saying, look, when we choose a new category, I'm immediately going to say that that's the category, even though it's going to take 2 seconds to save and a half second to confirm that saved. In the meanwhile, I'm going to thread this through here, and that's going to fetch the actual specific things. So the whole thing's going to be built on a house of cards, but we do the right thing so that it works consistently still. I mean, in this example, this whole thing, the fact that when this changes, this whole thing is optimistic right now. We're actually sitting in an optimistic override. The transition's still saving. Finance hasn't saved in the background yet. We're this whole area is predictive. This this finance could fail, but we've already updated the UI and fetched the data for finance, even though it hasn't saved yet because it's taken 2 seconds. It takes 2 seconds to save, yeah, 2 seconds, and then basically 2.5 seconds to do the whole thing. So technically, it's not just an optimistic value; it's an optimistic part of the graph, which is what I was trying to show here. It's like it runs in its own lane. That whole section of the UI is actually operating in a different zone than the rest. It's kind of already moved ahead to the future. Yeah, but like it is like optimistic things do flush immediately or do flush earlier. That is like what they do. It's just like it does. The part that makes that example a little subtle is it doesn't flush immediately. It does wait for its own downstream async. It's almost like a sub transition, and it still coordinates with the parent transition. Like it's still part. It's like trying to think. But yeah, I mean, this is the thing we gotta like consider on this is like how many people are going to use these tools to do stuff like this, like to kind of cheat it a bit. It's interesting. It's one of those like side effects of coming up with a design that doesn't care about the shape of the async, right? You're just like saying like, look, my optimistic value can also propagate its own async, its own kind of transition, and ultimately, if things don't work out, we have to be able to handle it in a single coordinated way. So, like, it's interesting. I don't think many people would set out this way, like in their head. Yeah, I'm not sure. Because if this wasn't async, you definitely would you could do this. You could be like, look, I updated it immediately and I showed it immediately. But then you're like, what do you do? Like if what if we make this into what is it, user category? What happens if I make this into user category? Now it's no longer optimistic down there. When I switch to finance, yeah, I mean this is the worst case scenario because it doesn't trigger the refresh. It doesn't trigger the pending until the refresh happens. But it's more like what you would do here, even though it's not passed through, is instead of relying on his pending, you'd have something process based, right? You'd be like, in here, you'd be like, updating category. But then you see the problem. Category display needs to know that, right? If it's process based, you need to pass it through. When it's data based, things get a little bit simpler because you just pass the data and the data encodes the fact that it's pending or not. Whereas if it's process based, you actually have to thread that information of loading all the way through. At first you go like, that seems like a big inconvenience. But when we were looking at Cobalt and stuff, most UI libraries are already set up to be that way. Like they don't assume like that you can ask the data if it's pending. I'm not gonna lie. There's been some discussion that where people are like maybe is pending is a mistake. I think because of the different behavior that it enables, and it's very important for doing things like reading above the async, like when you do page navigation. Like if you've seen, where is it? Tabs. Like when you're going from here to here, see how it grays out when it takes a while. It's good to kind of like be able to ask a question with no knowledge of the data below and just go like, look, this is part of this transition. Like we're waiting for it. See here, it grays out if it takes a long time. Like you can't see when it's fast, but when it takes longer, it actually fades a bit. But here, because there's a nested loading boundary, it never grays out when you go this way because it can always show the value immediately. I think as we showed at the start of the stream, where some stuff's based on data and some stuff's based on process, there is a clear use case for both. But it's the tricky part is figuring out how to encode that into best practices. It is definitely a superpower to be able to ask both questions, but how do you direct people to make the best composable things? I think if you start from a composition standpoint, it's like what we were talking about earlier. Like if you have a select list and that requires the options, then that's a data requirement. Handle it that way. If it's a button that triggers an event, then it's process based. You know, use your optimistic state affordance. And I'm hoping that pattern just trickles up. But as I said, when you start layering in lots of complexity, we need to like make sure that it does the expected thing. When I use data store, we respond earlier too, since it's just one it's in the middle of the thing, but it's, yeah, I mean, you can always model it. Like if the tricky part is coming up with a design for consistent, like consistency guarantees. The whole optimistic state model here and using optimistic data is like acknowledging the fact that like it's a speculative guess and it could be wrong, which is not a place, like some people are already uncomfortable with optimistic updates because of the fact that they can be wrong. But if you start adding like real weight to them, like optimistic, like further data fetching, all that, but like mechanically, you know, there's only like, optimistic aside, like forget the specifics, sorry, so not mechanically, but like just like structurally, you know that you only have two choices. You either wait for it or you pretend. And that doesn't matter how you implement it. So that ultimately has to be up to the developer, as long as I said, we end up handling it naturally. I don't think that's something that you can encode into the defaults into like how the framework works. It's literally the developer decides if they want to grab it early or not. Anyway, we started a place that made sense and taught, and then we ended in a place that is still open-ended because this is a work in progress. I'm very happy generally, except for these like last couple edge cases where these things are sitting though. Yeah, I mean, I think the let's not get mired too much on the details of the specific like overlaps, and just kind of reflect a bit on like this whole, you know, process versus propagation, get versus post mentality, and see how that reflects in the actual applications that we build. Because as I've shown in demos, it does definitely streamlines the writing of it. It makes it a lot cleaner, gives clear responsibility. What's up in the air for me is I don't know how obvious is for people reaching to the right tools, right? This exploration definitely had some really good conclusions to it. Is pending tells you something is unsettled, never why, which makes a ton of sense, because where's is pending on our chart here? The get side never knows about the process. It doesn't know why it's doing anything. The reason is the get side, you could do like a billion updates and then only pull it at one point and grab that snapshot. This side has no idea of what caused it to do the update, and it's intentional because it has no sense of time, no sense of reason. Optimistic state is often the loading state. Interesting conclusion, because the actual loading state should be loading, but it's optimistic state is often what you end up using for update states, because people think in terms of processes, right? This is not obvious. A lot of people think is pending is a loading state, but is pending is the readiness state, right? It's unsettled. Optimistic state is actually tied to the process, so it is usually actually the loading state, and later filters out background refresh noise. That part I don't know if I agree with. This was like an interesting side effect, and this is kind of like I actually have a proposal right now because of this split that we've been seeing here. Sorry, I'm going to open the right window. No. Because of the fact, like we saw it a moment ago when we did the optimistic fetching, where like it's not until the refresh that it realizes that it's pending. Like because of that problem, we've been actually working on like, let me see if I can pull it up here. We've been working on like kind of proposals or ideas on how we can deal with that. There was what do we got here? Packages, solid signals. Solid signals is a freaking giant library. It's so funny. Everyone's like, pull the signals out, but the signals library is like, it's bigger than solid itself. It's like the biggest code base in here. Effects. This was an idea I think originally posted by Friendly. But this is probably like one of the many options to play around with this stuff. Is optimistic was the other option, like so you can be like, if optimistic is impending, you can find the union between, or is it pending or is it optimistic, to kind of like get back that idea of like, is it updating? There's a few different solutions here, but like the idea here is, if you want to do the light up pending and you don't want to wait for the refresh, why don't you just tell it? You go, hey, this action affects to-dos, and then that way, or this, even the specific to-do, essentially, this row, and then refresh it. Like basically, or could affect it. Basically, preemptively mark the things that you should consider pending from a data standpoint. Because like, there's two challenges here. First of all, refresh everything, which often we do, is too broad. It triggers every row when you're just updating one to do. But you still usually do this if you use any of the kind of like React query type patterns. The second problem, which is there, so like, and then the second problem is, that's the second problem. The first problem is the one we already said, where you don't know what's refreshing until after the save. And the second problem is the granularity of that. So maybe there's a way of just kind of like tagging on it, going like, hey, this action actually, it's like, it's not saying like, hey, we're going to invalidate this. It's kind of like a predictive thing. Like this might be invalidated. So now tie this as the pending state, because you're just identifying that these are things that could change. It's definitely an interesting one. This is one way of unifying. We talked about is affected. I don't like that. Why not perform the refresh? The pair, often tying refresh is tempting, rejected as a primary form for three reasons. Wrong end of the window. Refresh fires after the wait. Target stiffer. Common shape affects a row, but refreshes could be the whole store. The pair isn't mandatory. A mutation may end up in a WebSocket push, a targeted store right, or nothing at all. No refresh to hang the declaration on. Exactly. This is a proposal that's worth considering. For example, sorry, is chat just dead? Yeah, have I lost everyone? Did I go too deep today? Sorry, it's been a while. Some people are here, yes. I think there's a certain reality of this that at this point, I've been talking about how there's like a fundamental physics here, and I've been diagramming it and showing how it works. but not everyone needs the exact details. They just need the categorical way to approach it to be like, look, this is optimistic state, this is pending state, blah blah blah. So maybe I am digging a little bit too deep into the mechanics. Might be valuable for framework authors that follow in our footsteps. But I think I'm even for myself, this is a lot to keep in my head. Didn't expect you to go this deep, to be honest. Yeah. Guess the scary thing is if you use this pending a certain way and then someone else does something that changes it. Yeah. Um, I think optimistic can't scale to a point, which makes me less interested in it. The thing is, and I've been trying to emphasize this, it's not just optimistic. See, I get where that is. It's not just, to me, optimistic state isn't something that I created. It's projecting something that already existed onto the plane where it should have always been. And I think there's a little tension here, especially from like on the HTMX side and stuff. And like that, there's a bunch of people who think that the client, like from a purist standpoint, the only gap between like what you can do with the SPA and like HTMX, where the client side is clearly a winner, is this idea around optimistic state, which means that there is a certain interest there. Because if optimism and this sort of mechanism of ephemeralism that's client driven is a real thing, then solutions that are primarily based on like HTMX type structures either have this gap or they have to adopt this anyways, at which point the fact that they're based on an HTMX structure becomes mute. So like if in a sense, if we succeed at this and say a feature like server components, which have partial support, it invalidates a whole section of the design space, possibly the space that Datastar, for example, exists in. And not that like you wouldn't still need specific solutions if you want like say WebSockets or like constant thing, but if our constraint is simply on stateless backends, i.e. things that are non-persistent, which is what classically been in for like SPAs or whatever, where like you can't know that a server's there, because there's still advantage to those other solutions when there is a persistent server. But if you assume that there's no option of a persistent server, the whole solution space collapses on itself. Now, if optimistic doesn't work, and it then it's a completely different story. So it's interesting because there are implications to where this goes. Like you said, most of your demos work either way. Exactly. Like we're getting to the edge of the edge case that people don't appreciate, but the devil is in the details, because this is the difference. But when we put all the pieces together, whether this is truly composable, whether this truly bridges the gap. As I told you at the beginning of the stream, I want to be more ambitious. I don't know if you guys snuck a look here when I was like on some of my GitHub, but you might have actually seen a repo that has my early work on a universal framework agnostic server component protocol. So my own answer to handling partials that preserve client state. And if this works, I believe, we will have united the different pieces in such a way that they're not conflicting. But I mean, there's a lot of ifs in that. So I'm not going to say much more than that right now, but I think that you can view this as a convergence. I'm not saying like when I talk about invalidating parts of the space, I don't think these solutions are suddenly going to disappear. I'm just saying that they'll naturally move into a convergence cycle. And I think finding that eye of the storm, this is one direction to take it. There's other directions. I'm very keen on seeing, for example, starting from something like HTML partials, like something Daystar, like where that gets when it meets to converge. Because like right now, there's only a couple frameworks that actually have my eye for that reason, and Datastar, for example, is actually one of them. I think but like part of that convergence is like you start seeing the pieces line up, right? Because if optimism is the way we sew time in and the lapse between server and client, we basically erase that lapse. That's how we solve the time in a way that can be client driven. If server components give us the way to handle partials that don't completely destroy state, and shared state can list on the client, so we can have both server derived state and client side state and unify it. If the still client based pieces can be more efficient in the way that they load in, i.e., like resumability and hydration pieces, uh, you know, I think all these technologies actually fit together in a way that's not actually at each other's throat. And the truth is, they don't have to be some large singular system. That's why I said I'm looking at like framework agnostic server components, for example. Um, it suggests, as I said, this convergence, and I'm very excited by the potential of that because it was too much. We got a bunch of money from Google to do research. The output of that was Cerevel, basically, the serializer, and some research that we did into stuff. But we were never in a position where we could actually deliver on what I had in my head. We just never had the resources. We would need like freaking Google or Facebook. But I think modern AI is changing that picture. My feeling is that we can. I know what the solution looks like, so we can build it. It's not as prohibitive as before. Bringing it to stability, bringing it to the mass is a whole other question and requires even more. But I think we can show that it's viable, and I think AI is playing a big part of that. Yes, I mean, people should have already been doing this. The key part is not just the affordances though, but the generalization of 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 the idea of like the types of state, right? I talked about this previously on a stream, and I might even be in here still, where I was talking about the layering. I think I mean, I might be getting too general generalizing. Did I not have it in here? But at some point I was talking about how, what is this? It's like a little bit too big. No, that's ancient. No. That there was like three types of state. And this is when I was talking about no, that's React timing. This is when I was talking about originally demoing that optimistic affordance state. I was talking about that basically you had the server, which is like the ultimate like baseline of truth, and then you had app state, and then you had ephemeral state, and they each live in their own zone and we've never been very good at defining the ephemeral state. Like all three of these exist regardless of your architecture. You might push more stuff into different zones, but where you push it doesn't match the expectation of like how it functions, you end up with friction. If you try to push too much to the server, then you get a certain type of friction. If you try to put too much in the client, then you get a different type of friction. And I feel like because our lack of understanding of ephemeral state, we've been construing certain, like we've been pushing things in the wrong place. And I think if we come up with the right lines, we talked about this on stream. I can't believe I don't. Oh yeah, is this it? Server client overlay, optimistic overlay. Phases, yeah, this is it. Phases of async and JS framework. Creation, do fetch as needed. Consumption, framework absorbs the promise as low as possible. Yeah, this is when I was trying to explain the difference between solid and other models. But the idea is like server, refresh request version thing, this. Like there's definitely a layering that happens, and I don't think you can ignore any specific part. I think different solutions have shown really interesting ways to make I drew these as arrows, but there's a lot of complexity in the communication and the interaction between the different layers. Um, and like a perfect example is like we talk about Quicks resumability in terms of the way they can defer hydration, but their mechanism for loading reactively loading JS as needed, essentially like using the reactive graph to load the JavaScript needed. Like you click this button and now I know exactly what part of the graph I need to load. Is an example of like almost like granular streaming of JavaScript, not just the HTML. That's an example of a very complex server to client interaction that they've streamlined that no one else has, right? In the same way, you know, what was getting talked about a moment ago with in terms of the server sent events and the data star stuff, that's a type of communication that they've optimized incredibly beyond other solutions, is incredibly fast as far as I've been able to tell along that certain thing. But these aren't all mutually exclusive. We just need the right model to kind of figure out where these pieces fit together. Yeah, oh yeah, I do agree. Certain classic approaches are the data star isn't capable of it just doesn't want people to make spas for other reasons. Yeah, I mean there are certain there's a lot of apps that don't belong necessarily need to be a spa. It's just I think the tension isn't like it's still app versus website tension. Ultimately, it's like do we have two models or a single model? And I think one of the hardest parts about RSCs is you're trying to they were trying to sell a separate like model to people who wanted a single model. Like people who build an app with React think they're building an app. Like they think that they're like there's a server, but that's like external data, you know, that does this. They're building an app, almost like mobile app. That's like the mentality you have when you build an app in a modern single page app framework. You're a mobile developer almost, and I feel like that's what made RSCs hard for a lot of people because they're just like, what is this? Why am I doing freaking PHP? Like, why am I doing like what? I will see how TanStack's like rough use of my design for server components plays out and if people like it or if they even use it. But there's a lot of problems that you know, it doesn't saying app doesn't fit the shape. It depends what the goal is, right? What I'm talking about here is probably the intersection of everything is obviously the most complicated version. The question is, can you pull it off and be performant and small? Obviously, if you cut out features, you would be even smaller and more performant. So you can definitely tailor something to a specific case. The question is, are we getting to a point where 10 years ago, jQuery is like 30 kilobytes that you're adding to every page. Can we keep the framework under 30 kilobytes? Like hit the jQuery marker that everyone was perfectly acceptable in the past, but have the capability to make something that spans the whole range? That's a question. I don't know. I mean, I do know, but let me pretend like I don't know. Unlimited Fable tokens. I actually made a joke to someone the other day. Like, this is what it's going to come down to. It's like, are are is the constraint now just going to simply be the cost of AI? If I set optimistic and immediately start an action, if the action finishes by setting a signal which has an async derived value, when is the optimistic state reset? After the async derived value settles? Yes. Yes. If you want to isolate it, you got to isolate it. It's like the other way around. But of course, if you isolate it, then it's a no op, right? But yes, it's transitions are ambient in the system. Doing one extreme or the other is easier because they make it as if the other system doesn't exist and sure it's worse than the optional solution. Yeah, yeah. I mean, optimally, I think you meant. Yeah. No, I mean that's the whole thing, right? So, sometimes like I've often said this, and you know that the compromise being in the middle is actually the worst place you can be. but I'm starting to think of this not as the middle anymore. I'm starting to think of this as like the future of the spa. Like this is actually just what the app solution should look like, where we're heading. And it's perfectly fine if you're not on the app side, you're on the side. I think that split, like the Astro versus or HTMX versus this split, will continue to exist. It's for a while. It's just interesting if, like, to me it's very interesting if I can create an architecture like RSCs, feels like a single app, has that kind of mechanism, and you don't pay anything, like except for complexity of the fact that these systems are in place. um you don't pay any real cost for that from like a end user perspective. Like, yes, there's complexity of having all these subsystems, like these pieces fit together, but the JavaScript is small, the pages load fast, the performance is great, you know because, like, I mean, it's an interesting question, right? Ultimately, when we bury the choice, we're not writing the code anymore. I, I choices will still exist, but the choice matrix will probably be a lot smaller. I think task text for RC is going to really low, though I must admit I haven't heard many people using it. Well, that's the thing. I wasn't sure if like it's a miss from the perspective, like when I even came up with that design, I'm like, is this going to click with people? I think most of those people wouldn't have wanted RCs in the first place anyways. Maybe it's still not accessible enough. Yeah, RCs and DSTAR are super different. I agree exactly. 'Cause uh, the but the like the Next.js implementation did put people more in an like HTMX side of things when they're thinking, because they realized like it was really in their face, like this is server, this is client. I'm making a server app that has client side stuff on it. That aspect um is like at 1,000 feet or whatever kind of similar. The difference is RCs were actually designed, like from an architectural standpoint, to basically be a single app thing. Oh, their whole reason for existence is persisting client side state. Jake from Notion, seeing the need for async signals in React. Oh, you're not gonna React not gonna have signals because signals aren't their model. You know, Async React is not very different from what I'm talking about. It's just less granular. I feel like we just have like a cleaner implementation and a cleaner API. Just, but philosophically completely aligned. People aren't. It ultimately becomes like an "are you need it" problem. I'm glad at least this is like kind of where conversation is, at least where I'm sitting. The best part about AI is people stop posting those stupid, like, look at how you write this in Vue versus React, or like that smelt meme where they showed like the like let count equals 0, and like those memes are never going to happen anymore. And for me, that was the most BS part of the front end anyways. So like, it's a win. Let I got a few other things. Let me pull up X now. I don't think I have very much more on the mechanical side of this, unless you guys have something specific you want to talk about. You miss CSS versus Tailwind. Yeah, I'm just saying, like, things that are based on like um how should I put it, these kind of like superficial things are becoming less important. That being said, there is value in some of the work on the superficial sides. Like, if making things easier for humans makes it easier for a computer, then that's actually a very hot area of research. I'm just glad that the average developer is not getting sucked into that. To be fair, the average developer is not getting sucked into any of the conversations we're having around frameworks. There's enough people out there that are of the opinion that JS frameworks are over. In fact, which ties me into what I want to do next. Let's watch a video from Kent C. Dodds. Does that sound like fun? Yeah, let's do this. I'm going to stop sharing my screen, and we're gonna talk that. I'm not. Let's share. God, they changed all my icons on it here. Okay, share screen, Chrome tab. Let's do this. Hopefully it's sharing. It's going to share audio too.
Is the question that Dax, why did nobody dethrone React?
Do you get? Can you all hear that? Did the audio come through? Try it one more time.
Why did nobody dethrone React?
I'm relying on you, chat, to tell me if you can hear that. Okay, perfect. Okay, cool. I like this take and I like this conversation because people who see this and respond to this respond to the wrong thing. A lot of them think that he's making the same take as Theo, which is React is the last framework. His take is actually less controversial and a little bit more yeah, it's less controversial than it looks like, and it's a little bit patting on the back, because I have to admit, when he first said this, I said BS, and I'm not sure it's BS anymore. So let's listen to what he says.
That is the question that Dax asked on X, and I've got my own take on that. And this is Better with Kent, where you learn durable skills. I've got some durable skills that you can learn from the history of React. Like, what happened? Why did nobody actually manage to dethrone React? And is it possible that that could still happen? And then, does it matter? So here's what Dax said. It's worth deeply studying why no framework dethroned React. It's completely misunderstood, and it's why every prediction you see by programmers tends to be wrong. And once you get it, you can apply this understanding to nearly everything you do. Oh, that is true. And I
have to admit that it's the very first post I saw when I got back from break, and I actually responded to it, which I can probably put a bit later. But I think the general takeaway when you when you see that is people focus too much on the like technical piece, right? I'm gonna let Ken give his explanation, but as you know, engineers were always thinking like this is faster than this and that. That it even the ecosystem argument is a little bit more nuanced than that. So, anyways, let's let Ken go.
Once I explain exactly what happened here, then you'll be able to apply this to everything you do as well. Really great take, Dax. So here, first I want to just say I feel really vindicated by this post, because way back in 2020, I was telling people, and even beyond that, this was just the earliest I could find on X, but I was telling people that React is the last UI library anyone needs to learn. And the reason that I believed that was because computers will take care of creating apps for us, which is kind of an interesting take in 2020 before ChatGPT came out. But I think back then, many of us could see that AI was slowly getting more and more capable, and it was only a matter of time before AI could start actually creating programs and stuff.
Yeah, to be fair, I'm sure Dax is referring to one very specific thing. And I'm not sure it's the same thing that Kent's referring to. I actually think Dax's post is actually probably a little bit more brutal than Kent's take, but so let's see here
for us. And so it kind of took a different shape than I expected it to, of course, but I think that most of us could see the writing on the wall that like, yeah, AI is going to get really good at writing software. And here we are. So why did I say that React is the last UI library you need to learn? Well, it's because it doesn't matter now which framework you use. As long as it's got like a bar of functionality, it really doesn't make a difference. For myself, I'm actually using
I actually, this point, I, at least the way it's starting, I actually disagree with. I think it does matter what framework you use. But let's continue.
Remix primarily for most of the active stuff that I'm working on. And the agent is really good at Remix with the right documentation and the right.
See, but then you put it there. He's not he's saying it doesn't matter because the agent like can write it. Like saying like any framework is very writable by AI. That's what he means by it doesn't matter, which is different than like when someone tells me that it doesn't matter what framework you use, I scoff them. I mean like you pull out the performance benchmarks, pull out the real data. Like there obviously there's always examples of bad apps and everything, but like yeah, and you can make good apps with React as well. But like there is a difference when there's like significant like user facing impact. Kent is happy React 1 is user 3. Yeah, which automatically already kind of tells you that his idea of last, like, this is not like the Theo take.
Skills. So it doesn't even need to be in the training data for the model to be good at writing code for it. I'm having a really excellent time with Remix. I've had exactly 0 issues with the model mixing up Remix with React. And Remix is like almost just like React in a lot of ways, but it like there's no hooks, there's a different like setup closure and a whole like a lot of things that are very different about Remix, and the model is able to just manage that just fine. So you don't actually need to learn Remix to be able to use Remix.
That's an interesting thing. Yes, but like anything, should you learn Remix to use Remix? Probably, because at a certain point, like this is assuming that you never need to optimize it. Like even if you're not writing the code, you might still need to like guide AI to be like, you know, this section of the page is kind of slow. You can be like, AI, why is it slow? And it might be like, oh, it does it looks and it figures it out. But okay, let's continue.
And so what I said all the way back in 2020 and before was definitely has already come to pass. You do not need to learn anything else. And that is why we can say that React was the last library you needed to learn. Now,
sorry, I'm just realizing I've been seeing these one-sided conversations. It's because I'm not sure my Twitch, I'm not seeing comments from Twitch maybe not coming through in StreamYard here. It's true for Rust as well. I mean, that's why I did my... To be fair, I don't know Rust, and I ported up something to Rust, so I guess that's fair. Yeah. So, okay. But I think that's the sharp, like that's the sharp point here. Why did I choose Rust? Why didn't I just leave it in JavaScript?
let's get back to Dax's original question of like studying why React was so successful. Here's my take. The success of React was functional at first, then social and emotional once it hit mass adoption. That's why.
I mean, that isn't that true of everything? It was functional at first because it showed people a way that actually made a lot of sense. But then once it's in, any like leading solution will have that kind of characteristic, right? Because people don't want to drop, people identify with it, you know. That's why one was never succeeded all the way to the point where it now doesn't matter anymore. I mean, people never, some people said that the new frameworks never did enough. That's fair. People stopped caring. That was actually one of my arguments that we'll get to. This doesn't actually, this is just common. This doesn't really explain why. It just means it was successful enough to be that early mover in the market that no one else ever caught up. And for some reason, and I think this is a more interesting question. Why didn't people want better solutions? Why didn't they invest in it? Because like, look, obviously if you don't invest in it, it's not going to get better. Like, I understand that if you like one person's building something, it's not going to compete with the team at Facebook. But you do have to kind of ask the question is like, is it true that things didn't get better? I disagree with that. So, yeah, let's keep
It
going.
won and was never unseated all the way to the point where now your choice of framework doesn't materially matter anymore. Now, some people came back at me.
Your choice of framework doesn't materially matter anymore. Yeah. See, that phrasing is way too strong. It doesn't matter in the sense of what you can write, but it matters in the case of what you get. Like I think what you hear. My current take, at least on the team-based projects, is to pick framework that makes the correct intended way the easiest way, and no way that's going to be React. I think support system for React is why it's still there. Compare that to jQuery or Angular that don't have that. Like, what do you mean support system? Angular has I thought Angular has like an incredible support system. You know, they have the whole GDE program and they have like Google backing. Be a little bit clearer what you mean by that. I'm not actually like in terms of community being organized in terms of like in terms of like communities like actively like I actually think Angular might be one of the best communities out there in terms of like actually like creating a community of people that are like helpful and designed to actually push it through. I mean, don't get me wrong, I love React, but React community reminds me of like when I used to play in punk rock bands and I'd go and we'd, you know, everybody was hipsters and they all talked about the latest band and React community very reminiscent of playing in the scene. Angular was like, wow, this is an organized structure where people care and they teach and they like, it's like people don't realize because of I guess certain popularity, especially in the US, but the Angular community is full of Kent C. Dodds. Like maybe not quite Kent, but like it's like there's yeah. The social aspect argument is that everybody wants to be cool and be hipsters. Yeah, I mean, no one cares about Angular. Yeah. And it's not because of some kind of marketing. It's just Angular wasn't cool. Angular was never cool. React was cool. They did the freaking mic drops. You know what I mean? I mean, as far as nerdy web development can be, and attracted people that. So like, why that was the case, I don't know. It could have come down to the early core team, the way they did the way they like established the community, but React has that attitude where, as I said, Angular is like the polar opposite, and Vue is, as usual, somewhere in the middle.
With this, and they were like, well, it was kind of useful that it was Facebook that came out with this, and yes, that does have some material benefit because it lended credibility so that it was worth people's attention, but that's not actually necessary, and in fact even became a deterrent after a little while. So what is the true success story of React? Why was React so successful? The reason it was successful was first because of that functionality. So yeah, of course, like Facebook comes out with it, okay, I'm gonna give it my attention, but you're not gonna hang on to my attention if it isn't functionally better than what I already have. And not just like marginally better, but significantly better. For myself, I was using Backbone.js and AngularJS before I showed up to the React scene. And when I looked at React, I saw a couple of things that were really unique about React that made it materially better than what I was using before. With Backbone, it was really difficult to make sure that my state and my UI were in sync, and I had to do a lot of manual stuff for that.
True.
With React, I had a simple state mechanism, and anytime I changed state, it just re-rendered everything, making it a lot easier for me to manage and think about state of data.
Just as a side, I think I agree completely with him in terms of what he's talking about in terms of this jump. I think the jump from React to the next thing, the gap is actually larger than the gap that he's showing here. I know not everyone agrees, but I think his second or third layering reasons are probably going to be more indicative of why people didn't move on from React, because the things that made people get onto React in the first place, the gap, but like React, they trusted it without, it having any user, like all the things that people use against other frameworks now as a thing was not any more true of React when people moved to it. You could almost view it as hypocritical. I'm not, because the situation has changed, which means that but if you hold the adoption of new frameworks against the adoption of React on the same ground, then the people who accepted React back then and don't accept other frameworks now are complete hypocrites. But as I said, things have changed, so that's not the case. But on pure face value,
changes over time, which is what state is. And so being able to manage that really easily in the UI was a huge functional benefit for React. The other thing that was really nice about React is composition. It was the first framework that really gave us the tools to be able to say, okay, here is a component that is reusable in many different places and composes really nicely with the other components. And so you can have kind of a black box here with minimal leaky abstractions. And then finally, the ability of React to just slip into an existing project was really powerful.
The funny thing is React's ability to slip into existing projects is true of any UI framework of that time period, but it's no longer true because frameworks like React don't make it easy for other frameworks to slip into them. Does that make sense? As easy.
As well. So the web is a unique place where people from all backgrounds and experience levels and everything, they have to have some web presence. And so you've got people who are doing Python,
there will be no
and
next
Ruby
React,
and Java,
not in the same way.
and eventually Node.js and JavaScript full stack. All of this, or PHP, everybody converged in the web and having to build some sort of front-end UI. And we're all going to have a different way that we want to do that. And so React's laser focus on just the UI was also a huge benefit as well, to be like, okay, you can use whatever libraries or write your own things for all the other pieces. We're just going to focus on the rendering.
To be fair, React was not the only library like that. Knockout was like that as well. Just going to throw out there.
Portion of that. And that was really significant in its ability to acquire adoption.
But yeah, Angular was more ambitious. Ember was more ambitious. But yeah.
So the success was functional at first. That's all that really mattered. Okay, we're going to give them credibility because they are coming out of a credible company. And so, okay, I'll pay attention. And actually, if you look back at the video and the comments on there, people hated React at first. But it gave them attention because it came out of Facebook. And then anybody who just gave it 5 minutes realized, oh no, this is actually really, really great. And because of that functional piece.
I agree. I saw React and I saw what was missing in almost every framework I used. I also saw React and was like, this is an abomination. It's like you threw out the baby with the bathwater. You could have just taken the one piece, applied it to something like Knockout, and then be in a way better place. But I did immediately see that there was they had changed the game. You could tell that this was the piece. I'd been circling around it for almost a year at that point, where I was playing around and I'm just trying to figure out how to split my view models. Do they go with the view? How do I make them reusable? How to make the dry? Do they go with the models? And I was having these structural issues, and React was just look, there's one clear answer. Client state married to the view, data outside. Done. That's the unit. And like when you could take that, I had a similar epiphany when I saw hooks too. It was like I was like working with signals, and I was like, how do I make sure that people don't cause freaking chaos, like that they don't go crazy? How do I keep things in line and don't cause like things to blow up? How do I keep things structured like the way React does? Saw hooks API, saw the tuples, and I was like, man, why can't I come up with this stuff myself? The ironic thing is, in both of those cases, their solution worked better for what I was working on than it worked for themselves, which is the irony of it.
Now, that is not enough because somebody could come later and come out with something that is more functional, has better performance, or has better other aspects that make it easier to write the code.
Yes.
And you can argue that Svelte and Vue and Solid and a variety of others.
In fact, all of them.
Now Remix, you could argue that each
I paused at the right moment.
one of these has aspects that are better than React on a functional level. But that's not why React has been able to stay on the top. The reason that React stays on top is because of the social and emotional aspects. Now, once React hits that critical mass, now everybody's just using React.
My personal why for React was winning is component separation that allowed you to scale terrible devs by not allowing them to step on each other's toes as much as other frameworks. Yes. I mean that was the key to it. The problem is that the fact of them not stepping on toes was only conceptually. They don't step on toes from the perspective of like commits and pushing things up. Do you know what I mean? Like they can work in their own lane, build their own features, and be completely independent. The problem is these graphs, because they're all part of the same React graph, aren't independent. So what does happen over time is those other teams or other people that you weren't thinking you had to worry about start causing your app to re-render or your section to re-render, and you didn't realize it. Like things are just as linked through as any other kind of graph. It's just like it's just because the model's simple enough, no one was paying attention to that. You could get really far without actually realizing that that things weren't actually that decoupled. I actually talked about this a little bit in my let's see if I can find the article. God, it's been so long. What did I even sign up? Was I Google on this one? All right, yeah, that was right. One of my older articles where it's like signals. See, can I do signals? Local thinking locally with signals. I do a whole thing explaining why React's model of component separation isolation makes sense and why it makes it actually truly composable. But in the conclusion of this article, I mentioned that the things aren't actually that isolated, and that's why people are hitting the trap, because essentially React couples the UI with the data. So even if people could be working on different data and have data isolation, they actually end up, because of the shape of the UI, end up potentially, I mean, it can work both ways, right? But they can actually impact each other just because the render cycle just bundles everything together. Like cooperative multitasking. Sure, one of them is more optimal, but the other allows Microsoft to ship terrible software. I feel like your take is closer to like what Dax meant, because it's like velocity was the goal, and yeah. React compiler, yeah, just like, yeah, we'll deal with it. Compilers should always, like, compilers are last stage optimization.
It's the easiest one to learn to get a job. It's the easiest one to hire for because everybody knows it. It's the easiest one to find a library for because everybody's building for it. And also because it is so focused, it adapts really well to however you're building your existing application. But everybody is using it, so everybody uses it. And
I mean, this is always a hard thing because everybody's using it, so everybody's using it is kind of like the argument. Like that's why anything stays on top. Um, but yes, it's a chicken and the egg problem.
And that is the social and emotional pieces. Like, I don't want to get fired for choosing the wrong framework.
And the irony of it is, at the time that they chose React, it was probably less tested than some other frameworks that they say no to, later.
And so I'm just going to choose React, and nobody will blame me if things don't go well because, well,
Yeah, exactly. No one got fired for choosing IBM.
everybody's using React. It's the same sort of concept as like nobody got fired for choosing IBM, right? So the things.
Exactly. The funny thing about the irony of that is, we know from history that that was like saying no one got fired for using IBM was one of the stupidest things, like in because of the personal computer revolution. Like it was like it's almost like ironic because of like how it ended up almost flipping, where it's like you should have been fired for choosing IBM.
Do change over time. And so the question is, well, okay, eventually another framework could develop some sort of critical mass, and now it becomes a lot easier to choose something else. But the reason that that didn't happen is because now it actually doesn't really matter. Like whether my agent decides to use React or Vue or Svelte or Solid or Remix, it actually doesn't make a huge material difference to.
Yeah, he keeps on saying that, but I actually disagree. I think this is where it falls apart because he's suggesting that they're all equivalent. And at first I thought it was just because you could choose any and you can just build it. But the way he keeps on phrasing it makes me think that he's actually suggesting that when your agent builds something with React, you're going to end up with something as good as some other framework. You might right now if the agents are better at writing React, but that's not what he's saying. He's saying it's good at writing Remix. So, okay.
Me because each one of those frameworks is capable of doing what the other frameworks are doing.
No.
For like most intents and purposes. I know in the comments you're going to be like, well, what about RSC? And like, I hate RSC, like whatever. Feel free to have those discussions amongst yourselves. Be very nice to each other. But I think that it's not.
I think this is I think this is the kind of basis. This is kind of like there's probably a term for this, something bias. This is kind of like the React developers have been holding this because at the same time, when you are on the most popular solution, you're going to assume that nothing is as good as what you're using, just because it's in your interest to stay on that solution, like that social aspect he was talking about. So it's easy to kind of like be like, oh yeah, they're all basically the same thing, but yeah, not really. Like at the farthest step away level, sure, but in reality, no.
Not really material ultimately for the vast majority of applications. And this is why I say it's the last framework you need to learn, because you don't need to learn any other framework in the future because the agent is going to do that. Now, some of you are saying, wait, Kent, you got to still read the code. You got to understand what it's doing. And yes, I agree that you need to understand the system in which your software is operating in and what your agent is doing. Yeah, you need to understand that system, but understanding when and where to use state, that is not what we need to be doing anymore. We are systems designers. We are product engineers thinking about the primitives that are available for our agents to use to solve.
Exactly. So the primitives that are available to use are actually incredibly important.
Our users' problems, and the specifics of how you manage state and all of that stuff, that's gone out the window.
I disagree. Almost all complexity comes from the mismanagement of state or hierarchy, like all the architecture stuff. Async is actually a prime source of this of this, where hidden waterfalls. You can act. I can't, because of my sharing mode, I can't show it up. But remember that diagram earlier where I showed jQuery and like you had UI and you just had arrows just jamming into it everywhere, and you could be like, wow, this is a mess. But if you notice, when I went to the React picture, I just the bottom, the UI part's nice and neat, but state is a bunch of arrows jamming into each other. That's still a problem, right? We literally spend a whole stream explaining why this is still a problem. Anyway.
Now, our agents are doing that. And so I am using Remix primarily, but I don't really know Remix very well.
And it's an interesting question. Why is he using Remix? Well, you could just say it's because his friends built Remix. But what you could, like, you see, on one hand, you could say it doesn't matter because they're all about the same. But if they're all about the same, like, this is an interesting double edge. Let's continue.
I know like a couple of things, but I've never taken time to sit down and really learn Remix because I don't need to. I just provide the documentation to my agent, and it does a really, really good job with that. Now, if you're building a framework, then that's great, and you're going to need to spend a lot of time thinking about the APIs and everything, but your consumer, your user, is the agent in this case. Now, let's bring it back to Dax here. So he said it's completely misunderstood. I agree. I think some of you are going to have a different understanding, I should say misunderstanding of how and why React was so successful. But let's talk about the once you get it, you can apply this understanding to nearly everything you do. Now, the interesting thing about functional, social.
Well, there's a book on this. You guys ever heard of it? Called Crossing the Chasm. It's like, I actually read this because people were trying to help me like figure out how to get from the front, crossing the gap to get to where React is, right? They're like, from a business standpoint, how would you approach Solid as a business if you wanted to take out React? And the problem I had at the time was it's open source, so like there's no like money angle. So like, and you're like, show something that you're specifically better at React at, and it's like, and then market that specific thing. And it's like, if you try and play it out as a niche player, that's probably the most successful way to get across the gap. But it's really hard when you know that your actual selling point is being general. I mean, the problem is, and this is the part you can apply here, is it doesn't pay to be better than the most popular solution at everything. Like, people always talk about, oh, you gotta be 10x better, and I made this whole thing up. It's not. I think you can be 10x better and still not like, and be better in every single vertical you can think of and still not make a dent if like if people like if it isn't in a realm that people are actually measuring, or that they like as Kent was saying, like according to Kent, it doesn't matter what you choose. The funny thing is that, like, if you go to large companies, talk to like eBay or people doing e-commerce stuff, this stuff matters. Shopify, this stuff matters. But if you're talking the public opinion of the random people on Twitter, and like we already talked about the social, the cool hipster thing, maybe it doesn't matter. Let's keep going.
And emotional aspects of
Right.
the success of React, that's job.
So in the sense, this is true of any sort of technical venture, not specific to React.
Theory, and I made a video about that a while back, so you can go take a look at jobs theory video that I made. But the basic idea is that people will evaluate different products like they are hiring different employees to accomplish a specific job that they want that product to do. And so you hire it based off of its functional, its social, and emotional needs that it satisfies. And so, like I said, at first it was all functional, but then everybody kind of got to this basic same level of functionality. And so now you have to differentiate yourself on the social and emotional.
Yeah. See, this is just like first person there lead. The truth of the matter is, things exceeded React on functionality, but they were already playing against these other points.
Needs as well. And that is where React won, because it was just so ubiquitous.
Yeah, by the time anyone else could get
Its
in.
ecosystem was massive and all of that. And much to the chagrin of the competing frameworks, that was the fact. And it was very, very difficult to beat those network externalities.
Very difficult.
So applying this to whatever product you're building, I think you should just learn jobs theory and apply that and figure out, okay, what's the job statement that I'm going to use as my North Star for guiding this feature in my product or this entire product or like this internal tool that I'm trying to get adoption inside of my company for. Whatever it is, it's jobs theory. That's why React was so successful and why React was never unseated. If you disagree with me, throw that in the comments.
No, I mean, and that's where the kind of conclusion comes down. And yeah, I don't disagree with Kent from that perspective. Um, I'm actually going to switch the way I'm sharing my screen because we don't need audio anymore. One sec. Uh, what I actually respond to this when I say is I like this angle because it both completely also talks on access is meaningless to me. And the reason I don't mean it's completely meaningless. I definitely think about these things. It's just like when I built Solid, it wasn't because I was looking for adoption. You got as someone who's like a single developer who literally was just working for some company, just building a thing on the side, not working for a big company, not seeing like a pathway to being mass adopted, not seeing any of that kind of stuff. Not even really having a wide like Rich was working for the newspapers and he saw like a real need, where he was like, look, we have designers coming, we're always building these quick projects, we have to lay up, we put them out, we need something that kind of fits our pacing. Like Rich had a real reason. My reason I was kind of was that it's so funny people think, but I saw some solutions like Knockout and some like the early solutions. I saw React. I saw what React solved. And then as an engineer, as someone technical, this is not how you get adoption. As I said, adoption was the farthest thing in my mind. I was like, this is not the best technical solution. And it never can be. It's just fundamentally limited. And from that perspective, I just was like, okay, so how do you actually build something that carries these consequences, but is actually does the job, right? And I've approached everything I've done with Solid since like that. It's been a quest or a journey to find the best way to do something, right? It was never about, oh, how many people are going to use this, right? And that's the difference. Like, a lot of times when people make products, they're selling something, right? They're like, I need to get market fit, and then I'm going to get this, and I'm going to get users, and that. I for me, the criteria was very, very easy. I needed to have empirically good results. I needed both to have good performance from benchmarks from like real use cases, and I needed to thread the needle where stuff was sane enough to reason about. So like a lot of the time when I see this kind of discussion, you know, like from my perspective, these things will never be equivalent because there's so many different aspects. I'm way too deep. So when I look at something like AI's impact here, I come to slightly different conclusions. Even like, and I hear those conclusions even when I hear Kent talking. Like, I love that comment. For sure, in the way he presented it, you just got nerd sniped. Yeah, probably. Yeah, because like that comment about where was it early in the chapter is like he talks about React winning and then he uses Remix, right? And he mentions it like multiple times in the video. It's it it's actually suggests something else, right? Um, and I kept on thinking about I was talking to Dominic Ganaway the other day, and we were talking about he just started working I think at OpenAI, and I was like, and we talking about the way coding changes and the way we write with frameworks change it. And I said, I feel like I'm writing assembly code anymore, or I write assembly code now. That's what I said to him. And but when I said it, I don't mean that I'm writing assembly code when I'm making Solid. I mean that like what I'm building, like when I'm building Solid, I'm actually like designing an assembly language. Like I'm designing a lower level language that people aren't necessarily going to use directly, but the decisions I make are incredibly important in terms of the efficiency of what the final output is. And it's funny because then I saw this from Kent and the rest of the piece of the comparison. And I was like, little history. There was lots of different chipsets coming out of the 1970s into the 80s, the rise of the personal computers. Everyone like had their own like there's all these little boxes. I don't know if all of them like if there was so much in the different architectures. Like I don't know if like those old like I think AT&T had some, and I don't know if all of them were different or they designed their own chips or if they all just use x86, but there was more than just x86 in the day. And anyone knows Mac had like their Power Macs, which also had their own chipsets. Basically, at the early days of computers, it wasn't just like which manufacturer you had. You actually had different chips competing. Obviously, as we know from history, Intel and the x86 architecture won, but there's a big discussion over small Little Indian versus Big Endian, which is like which side of the bit, like which side was like the big bit versus the low bit, like which one was the like when you laid out the bits, which side was like the most significant versus not, and like whole difference in like these things were kind of like still getting figured out. So when you look at CPU wars, there was a time where this was actually a battle that was being fought. And then eventually, especially when Apple pulled out of the game and they in like around 2006 or whatever, they ended up adopting Intel. I mean, Intel at that point had just made the sweet, like such a good move. What they'd done is they'd taken their mobile chip architecture and actually replaced their old Pentium, architecture, still x86, but essentially they downshifted it and they realized that they could take their laptop architecture and apply it to desktop. And then this change, we weren't getting Moore's effects anymore, where things are getting 2 times faster, but it was better for heat. It was better for parallelization. They're getting to a point where they couldn't like put any more cores on the CPUs because they're like freaking melting. Pentium 4 generation CPUs had the craziest, like they could handle the heat, but they had the craziest heat threshold. If you look at CPUs now, nothing gets even close to that hot anymore. They actually like had to build around that constraint. The heat, the problem obviously is you can't shrink the silicon much further because like it just stops functioning under those conditions. So they actually had like the game had changed. They pushed the max in terms of cooling and all this stuff, and they actually had to change the way that they actually built the chips and laid them out so that they could actually continue to make progress. Part of it was multi-core, but more of it even was just they had to like deal with the way that they handled heat, so they can continue to shrink the silicon. Anyway, right. I think Reactive is a DX thing, but yeah. I mean, sure, but I mean, I don't know. You could argue that Svelte was like another DX leap. I mean, the funny thing for me is React Index. I feel like I think of React Now, and it's React Now is definitely, even 2016, 18 was better than what I was using in 2012. But like, I had a pretty sweet setup with my Knockout using Jade templates and stuff. Like, the way I wrote code looks actually a lot the way they wrote code with React hooks. I don't think that you know what I mean? Like, people who from jQuery, sure, but from like, I don't know. I thought even Angular 1, like the DX of like, writing some state variables, have them like that whole like, I mean, don't get me wrong, there's a problem with debugging and optimization, but general like here's some state, render it. Chipset is great. It also explains that both true and you won't be fired for buying IBM, and then in the end, a different architecture won eventually. Yeah, exactly. Because what I'm getting to here is that Intel, took over and they completely won, and you were ubiquitous, and no one cares. And at that point, people stopped caring about CPUs. No one like was really advertising CPUs. But then what happened? We needed something even smaller. Mobile phones took off, completely different platform, and like laptops before them, had even more different heat constraints. And in fact, I don't know who made the decision, but they over time, ARM as a architecture existed back in late 80s, 90s, like during that time period. It wasn't as big, it wasn't popular until it already got its hooks into the bigger players and all this. But it was just like a footnote, right? I'm pretty sure. Like, sorry, when was ARM created? Let's see if we can find it. 1990. There you go. So like, but quietly in the, it worked into these lower end devices. It was incredibly efficient. It uses a smaller instruction set. And next thing we know, 4 years, every single mobile device is using ARM for their phones and laptops and all this kind of stuff, which, it's fine. Like this is not touching the PC market at all. But then, like at a certain point, you start going, if we have a more efficient architecture, I mean, and then there were adapters like over the x86 instruction set to kind of like trying to do parity, but it's still just a patch. You know what I mean? Like if we have more, why aren't we just using it, right? And slowly by slowly, and it's happened mostly in the last like decade. First of all, like the M chips from Apple, those are ARM. You go buy a Windows computer today, you'll see like Snapdragon, powered by Snapdragon, like some of the more like popular, like pushing the line laptops. Sure, they might not be the most purely powerful, but because of the efficiency numbers, you're starting to see ARM even translate into the initial Windows space. But the M chips from Apple were such a significant jump. I remember getting my first M1 and being like, wow, this is just crazy. Obviously, part of this is now we use laptops, but it's the same thing again, right? Laptops processing became desktop processing when the constraints reached it, and then mobile became laptop when we reached it. So like, this is why the thing is, they won the CPU wars, but I would say ARM ultimately is going to be the winner here, even though x86 was ubiquitous. And people in the know still had to make a technical decision that mattered, right? Even though, I mean, if you want to talk about lock-in, x86 feels really good because all software that's been built for like 30 years, basically ran on x86. How do you possibly leave that? And the thing was that eventually Apple decided that it made a difference on like their battery life. It made a difference on like what performance it could give. It was a big enough difference for their product that things had progressed far enough that they would make the switch. And at a certain point, it was just a facade sitting over you just they got to a point that they could even like spoof x86, for a compatibility layer, and for most things be good enough. And now here we are. Yeah, I guess Felt did have no TS for a long time. That's a good point. Why won't everyone build their own CPUs and given that's just much cheaper because because someone has to maintain them. I do think there's like, when it comes to the more opinionated pieces, you will see that like meta frameworks are kind of, the encoding the opinionated parts is a place where you're going to give more like, there's that old saying like everyone needs a framework, but or it's something like generally everyone needs a framework, but not everyone needs a general framework. So some kind of statement like that. Usually that part, the opinion encoding stuff, is going to, AI is going to take a lot of that. People might have, and don't get me wrong, there's people like Tanner who basically like clone the parts of React they want, but those solutions now you're on the hook for, and they don't necessarily tell a complete story. What we're actually doing with JavaScript frameworks is inventing a UI language. Think of it more like isn't it like I don't know, like the difference between C+ and Rust. Recent one, not the Intel was good, but NVIDIA. So I'm just when I think of NVIDIA, I think of them versus AMD, not versus Intel. Um, Biggest cost of switching is that you need to rewrite software and write new emulators. All stuff that is easy to do with LLMs going forward. True. But yeah, I just, this is an example of where lower level decision still matters on a technical standpoint. And over time, when you remove the friction, people will just choose the better solution, which means that this is why I don't, if my goal was always just to come up and work through finding the best solution, then none of this actually really matters. What I'm saying is it's convenient to write off the impact of lower level decisions. In fact, let higher level abstractions make those decisions for you. But that isn't a sign that the goalposts aren't constantly moving. You might not need to write code, and you should still understand the high level impact of your decisions, right? Because I was saying, like, you're not writing assembly, but x86 versus ARM has an impact. Ken's to understand can be correct because you framed it as you need to learn, as in learn to write. But in a universal sense, these things still matter. Differences still have profound impact. So it's good as long as you don't equate last framework to learn with last framework. Yeah, that's why the stuff. You're right. That I got a little nerd sniped into this. But for the most part, I don't think that, like, I think it's probably like worth talking about again. It's been a few months. I know we talk about this too much. But like, when did I come back? It was here, July 1st. This was my original take where I was talking about this discussion. This is my answer to Dax's thing. I thought the answer would be awesome. It isn't about technical merit today. There are better solutions. It isn't about ecosystem. If people are present, those build themselves, right? Like Kent was talking about the emotional aspect or the social aspect. Yes, but it's chicken and egg. If things move on, eventually people have to move on as well. It isn't about history. That explains unprecedented growth, but it doesn't explain staying power. It's about complacency. And I don't mean necessarily in a negative way. If there's no incentive to know better, to understand your own tools, how things move, if perceived complexity of the space itself deters growth, and decision paralysis, i.e. JS fatigue, who's going to spend the time? If higher level abstractions like AI pull us away from mechanics, what are we doing? The mechanics of what we're doing. Are you measuring what solution is more efficient? Good enough as a mantle becomes alignment to many factors. Yeah. So what I'm trying to say here is, like, a part of it is like perception of this stuff got too complicated. Like when we got to the point where people were trying to say, oh, this framework's better than that framework, it got to a level that it sounded like noise to people, right? Where React came in, they had a very clear narrative. It didn't even have to be completely true. It just had to be clear. And no one really could argue with them on that narrative. But after that point, you know, it's very easy to be like, oh, you know, like every single thing that React used coming in, it was very easy just to kind of like devalue it later, be like, oh yeah, you know, oh, it's just a little bit performance. Let's make fun of that. Like I remember people, like, especially during the JS fatigue part, when someone said they came up with a new framework that was faster, it was almost seen like so negatively. Like we got past that point, but there's a couple of years there where it's like suggesting that something was faster was actually seen as a negative almost. And I think, which is like, makes no sense from an engineering standpoint, but it was just like people had enough. Like in a sense, I think for a lot of people, front end is supposed to be simple, and things are already such a complexity that no one really wanted to get into the details of why these decisions are made. If you like, I think this is largely cultural. Like if you look at a lot of like different types of engineers, you talk to backend engineers, the Primogens of the world, they love to discuss the technical merit of their solutions. But front end on a whole, I mean, it's fashion, right? Like there, there's like a different type of developer that was attracted to working that much closer to the end user. It's not the whole population base. We obviously have people, who care to dig a bit deeper, but like there's always going to be a portion of the people that don't care, and that's going to be the vast majority. And then there's going to be the people that do care, but what do they care about? And if you have a profession or place where like front end developers aren't seen as real engineers or whatever like that, you're probably not going to attract the people who value real engineering. Do you know what I mean? Except for like when you get deep into these large companies and you find that those are the people holding the gears. You come across like a Michael Rawlings or Dylan Piercy, somewhere deep in the basement of eBay, so to speak. Then you'll come across those people. But out in the wild, not so much. Yeah, front end's all about look what I created in 15 minutes. Yes. The whole thing incentivized. Yeah, blazingly fast became a meme, which is kind of like blazingly fast. Yeah, I get it because everything was faster and faster, but that's a good thing. How could that ever be a bad thing? Yeah. In terms of like the ecosystem aspect of it, because when you're that close to the product, maybe it's not viewed as engineering. And I disagreed. When I was working on these complicated situations, I'm like, this is engineering. This is complicated to solve. I'm still working on these problems years later, and they're still complicated to solve. But I think front end engineers have been told this for so long that some of them might have even believed it. So what you were left with, if I'm again, won't make sense to most of you people, but from Magic metaphor, you were left with a bunch of is it players, is it spikes if you want to know it, and that probably makes no sense to almost this whole audience, but if you know, and that just basically meant that we were kind of like a lot of the aspects were for show. It was like it could happen. Like it wasn't about it wasn't about like grounding it in actual numbers. I don't think it's something that should be celebrated. People who called that might be right, but they also made the predictable call. They hedged on shorting the market. Yeah. So like it's always easy not to hedge on not innovating. Like if something's popular, like if you're given a table and you see like this has 80% market share, this has 10%, this has 5, and this has 2. Pick which solution you think will be most successful in 5 years. You pick the one that has 80% market share, right? Like this is you're not a genius for calling this out. But like if you don't spend the time to look at the other solutions, you know what I mean? You're just kind of like betting that things don't change. That's the easy bet, because then you don't have to do any work. So like, oh, and to be fair, when React has changed itself. So when I say it doesn't mean everything starts with React, I mean like old React. When people talk about React in these contexts, they're not talking about async React in 2025. I'm not nearly as critical of that. They were talking about this perceived React from, maybe 2018 time period, and that's React for them forever. So in a sense, like they are mirroring the AI. React has changed, but we're still mired in 7 years ago or 8 years ago. Space think it just means that the pathways to React success sort of won't look like React. I don't mean API wise. The API could look similar, but that the way it is adopted won't follow the same path as React. Yeah. And this is back to my thing. JS frameworks are no longer the frontier of the abstraction layer. In a sense, they haven't been for a while because the meta frameworks started becoming that frontier. In my opinion, we should start, the meta framework layer is a temporary layer. It's going to get deconstructed. Some of it's going to fall back into the frameworks. The other of it's going to fall up into AI. But it means that I think the choice in the future is much closer to the ARM versus x86 choice, which means that the fact that React won also doesn't matter, because ultimately, if it's not what you're interfacing with, eventually you're just going to pick the better solution. This is I won't call it complacency. The improvements offered by others simply weren't big enough to overcome React's inertia. But like the perspective or what decides big enough is driven by perception, and that perception is anchored in social or cultural mechanisms. I don't think it's a technical bearing. I think like if you wanted to come up with any criteria on a technical stance, you could easily argue React should have been supplanted. That's again not what's important. That was Dax's point. Engineers often get too mired in that side of things. In a sense, front end and the Reacting is much more reflective of a typical product space, which is kind of funny. Anyway. Yeah, I actually funny. This post was actually a reframing of this whole stream. Work through async React, it's become clear to me that core concepts need a bit refinement. UI function state has served for a long time, but it's only really one half the equation. Server focus the past few years echo this, blah blah blah. The trick hasn't been to force everything into a familiar model. Think async the way it appears to, but isolate propagation from process. Yeah, we talked about all this. The implication is one side never knows why and the other side never knows how, but the result is much cleaner when trying to trace both at the same time. The challenge is getting accustomed to classifying the parts of the solution this way. Yeah. I thought this was funny. This is like, anyone who doesn't know, Jordan Walk was the original creator of React, and it feels like he stepped away right like in 2015, right when the change in the guard, when Andrew Clark and Dan Abramoff and all them came in, and that's when Seb was on the team, but that's when he really stepped up, and like the whole hooks thing and every place where React has gone. So it's funny to have the original guy go like, I kind of miss class components. When building complicated imperative components instead of using hooks. Hooks are fine for a couple imperative things that mixed into declarative component. When the entire component is a giant ball of hyper-optimized mutations that avoids re-rendering in most cases, bridging to several external side effects, is it wrong to use class components? And this is essentially like the Remix 3 theorem. It's saying that like at a certain point, your app will get to a point that React evolves into this. Why don't you just make that the system and remove the complexity? What's wrong with having a very ugly imperative implementation of a very ugly imperative component? The beauty of React is that it still exposes a very declarative functional interface to make that madness. Yeah. My version of this is, why can't I just stick all my logic in one giant create memo? Hooks is a relic prism to get. They may have not been intentional, but their setup makes people hallucinate signals. And I think this is actually the thing. The React team, I guess, it's so funny how full circle it is, because Jordan Walk was involved when they basically back when Tomachino and that time period when they basically were breaking apart all or Pete Hunt favorite Knockout and all the reactive libraries at the time. So they all left, and then hooks came in, which have a lot of the same properties and look of those reactive libraries. But the problem was that the old class components had a real problem with compositional aggregation. We talk about React being really good for being composable. But the problem was people wanted more control than what they could do at a component level. back in class components, because you have the different life cycles split it out. Again, and this is related to our conversation. It's like that conversation on time. Life cycles in class components is an encoding of a specific time variance where you have the split stuff. It's hard to compose. Whereas when you switch to hooks and those collapse into single concerns based on the particular data, you're making it data centric. It gets a lot easier to have these pieces be reusable. So like, and that's what I mean. Compositionally, aggregation is generally better than inheritance. That's the thought. If you have the building blocks like Legos, it's easier to compose by kind of like picking the ones you need and sticking them together than creating a system in which, like mixins or inheritance where you're saying like this component is such a thing. It has these characteristics in its life cycle. But like the impact of this was profound. They forefront the true mechanics of React optimization. In one sense, this is what created the re-render outcome, but it was also what gave you the tools to manage it. If there's a lesson we learned, it can be messy to break things down smaller than your library's smallest defined unit. And this is the thing. That's what I meant about them hallucinating signals. The second that React added hooks, like added a mechanism of something that was seemingly independent, but actually changed the behavior of the runtime of the thing of the shell it sat in, you basically like there's some kind of, I don't know what it is, but some fundamental law was broken, rule was broken, like because what's so clever about them is that they aren't really an isolated thing. They're actually just mutating the underlying state of React, but almost all the complexity stems from that. The hook rule ordering, like everything stems from this. So like, how did I, is that where I concluded? Yeah, that's where I concluded. I think, and it's selfishly, I think hooks are like a really good thing, but that's because I like the compositional direction they did. But so when I look at hooks, I just see like worse version of signals. So like, how could I not like them directionally? Because they actually solve like the life cycle spaghetti, the thing that Remix is trying to bring back. They actually give the tools to solve it. It's just those tools in that form might not be the best form of them. So it's like this kind of love-hate split here. Code bases stay on hooks, so I have to imagine I'm not the only one that feels that way, but it's very interesting when you kind of step back and the original creator React is kind of like, like it's okay. And the truth is, it is okay. In a sense, though, if he wanted to, he could probably model whatever he's talking about inside one very large hook. Maybe not. I haven't seen this situation. I'm not saying it would be great. It's just a thought. Hey Fuzzy, it's been a while. Calling friend in fashion is pretty descriptive, yeah. Anyway, food for thought. It's kind of like it's kind of amazing when you consider how simple React was at the beginning, and they've kind of grown to try and fit this and kept pacing. I mean, it's impressive. It's also very ironic in a sense that you like part of me thinks that like if we'd taken a different turn right when React was introduced, we could be in like a much better place. React is like the tale of like the unexpected underdog that somehow won. It's kind of crazy. That's why there's a certain amount of respect I have on that anyways, just because when you think about it, like in the scope of solution space, React success is almost surprising. It just like the timing and the fact that what it offered at the time was a real thing. It's just like, but when I look at like all the different possible potential solutions, like it's surprising that it's where we ended up. Talked about its pending already. Talked about Kenzie Dodds. Yeah, I mean, I don't need to keep on going. I got some more solid releasing and work to do. So for me, I think I already talked about this a bit. Um, with the Rust compiler and all that kind of thing. But the new models are something else. I haven't played with the latest like I haven't played with Soul, like 5.6 Soul or whatever, so I don't know where this is. But Fable, um, I know this is how I started the stream. Like, I don't know. I think other people experience it themselves, so there's nothing really that interesting in this, other than the fact that in my specific line of work, where I have to make decisions based on like multiple code bases, like in terms of like creating a system, having that kind of in-depth reasoning is like invaluable. Um, I think the only takeaway, and I think other people have talked about this too, is and this doesn't impact everyone, but I think especially in open source, we really need to rethink about how we think about feasibility. Um, it is really quite it is really quite profound. And I mean, I'm sorry, I just sound like a broken record here, so I'm not going to stress on this, too much. It's just I I don't I don't think I would be nearly as ambitious as I am right now if it wasn't for this stuff. Like Solid 2.0 was coming at a decent pace, but there's no way it would have been the quality of where it is going to be, um, and come out when it does if it was not for this. And I'm understanding that just for me and Solid. I have to imagine this is for all the other competing frameworks too. Like this is not just limited to my specific work or that. It's kind of crazy, like how tested React was when people picked it up, and then since then when people don't switch to Solid or Svelte because they're like worried about you know like how stable or what our thing is, and they've been around for like 5 years plus years, and you're like, no, it's way better than React was at the time. The quality that's bar raised by AI here, both in like security and like all these other kind of aspects into mechanical and bugs, means that these solutions now, when people spend the time and the dedication, like, yeah, anyone can go make a React clone over the weekend or something, but a partial clone, like what Tanner did. But when you have the engineering expertise and the people who understand the problem space actually working on it, like the people like they've already been, and you apply that to this, you don't need a 60-person team at Google to get the same kind of results anymore. That's the difference, right? It's not like the work goes away. It's not like you don't need people working on the framework. It's just like, and different perspectives. It's just like the raw resource number is a game changer. And like, I'm already seeing this with Solid 2.0, which makes me want to be more ambitious. I was always very careful and cautious to make sure we don't overstep, make sure that what's maintainable. That's why I never did Rust before. But now, I mean, it's so funny. I've had a backlog of ideas that I wanted to solve, that like to show like where we are today to get to where we're going. And I feel like in my head, I was like, that's going to take me 5 years, 7 years maybe to actually finish the story arc. I feel like with AI where it is right now, it's we could get there in 1 year, um, which is insane. I'd be very excited a year from now, stepping on stage at a conference talk and being like, "Hey, remember that facing front end essentials crisis? Guess what? We've solved it." But we will have to see. Give you all about a year removed with the parents are long. What's that thing, like the definition of insanity? It's like trying the same thing over and over again and expecting different results. Anyway, curious with Solid to what? Sorry, curious Solid 2.8 solution to what would be. Maybe we covered earlier in the stream, but what's the plan for solid the rest of 2026? Okay, yeah, let's talk a little briefly. I did talk a little briefly about this, but yeah, sure. Beta's going great, really nailing down stuff thanks to these, like, God, big thanks to the, like, I don't know the names, I don't just the GitHub names, the people who are basically driving Solid 2 off AI testing and examples, people like Brenly, people like Gabriel who designed, like, it's funny, I didn't officially set up like a 2.0 team, but they've kind of formed, and it's a different shape. It's not like, like all these people are actively writing code, right? But in fact, I'm guiding most of it, and it's just that there's people spending the time building the examples, like, starting way back when Dev was starting, to people like pumping AI through this, to the point that there is definitely a core group of people that have been really pushing this forward, and they have a huge thanks from me, which means that, like, I went away for 6 weeks. Last time I did that was right before the solid start, or right after the solid start release. No, right before the solid start release, about a year ago. Yeah. Yeah, two babies in 2 years is a lot. Uh, and this was 100 times different. Before, I was just happy that things kind of, like, moved, and, like, some people. This time, I felt like we didn't even skip a beat. Like, it was just like, with the testing, you just step right back into the issues fixed. So plan is next 3 weeks or so to a month, really work through the beta, get that RC ready to go. Ecosystem, I mean, it's a cat and mouse game with them. They know it's coming. Stuff's been stabilizing. All the, like, main behavior has been there, and it's been there since before I left. So things are progressing. And then we're going to run the RC probably for a month or two, really make sure everyone's on board. The hardest part is actually convincing people to try it. I'm hoping with the RC, and, like, the docs are already flowing, we're already generating the docs. I'm really hoping when we get the RC going, people will actually push it. Eventually, I'm just gonna have to pull and be like, we're gonna release it. But yeah, tentatively, I think we're looking early October ish, right? We'll see where we're at, if things go faster or slower, but, you know, probably be awesome to get it out by VConf this year. Actually, is VConf? I've been so out of the loop. I don't even know what's up with VConf. Because last year I didn't go because I still can't go because I have there's no way I'm traveling, but nice to put a talk together for that. Basically I'm thinking, the way things are heading, we're looking early fall, like early October, for Solid 2.0 stable release. That's tentatively, but yeah. So, all right, 5 hours is good enough for me as far as I'm concerned, and I can get some more work in for the next hour and a half. I really want to get the compiler out, as we saw earlier on the stream. Apparently, it's up to 300 times faster, so I'm sure somebody's going to appreciate that. All right. Thank you all for joining me. I think I'm just going to call it, though. So you all have a great one. And again, it'd probably be every 2 week intervals kind of been my go recently. So probably no stream next week. We're not going to have enough topic, but hopefully you found something interesting or valuable. And see you all again soon. All right. Have a good one.